Where's the VOD YouTube? Hold on, let me find this. Oh wait, did that start up over there? Wait a minute. Did I close the social stream blade too? Probably have to open up all the pages again. No, it's still open. Right there. And then, oh, I see. Yeah, that's the moderated chat. That one automatically updates. This one is no longer, if I hit test on that. Oh, that did come through, but this live chat is no longer available. Oh, wonderful. Hey, what's up, Madamu? Yeah, see, that didn't, the Madamu comment didn't come through. I need to actually open up. Hey, Sfar, how's it going? Hold on, I gotta open up the, oh bother VOD page. And then we gotta open up the live stream, and I'm gonna mute myself, and then I've gotta open up, pop out the chat. Now, presumably, test. Yes, okay, cool, that works. I hate how my main account is my full name. I need to change that. That's obnoxious. I shouldn't be outing my full name that readily. Go away, get out of here. Can I like delete the comment? I don't think I can do any, delete message. There we go. I can delete it on that page, and that's the only place I have agency over. All right, how's it going, everybody? Welcome to Friday. I woke up recently, so my hair is probably still wet, but from showering. But yeah, we're doing microcontroller math today. Like, you know, IMB here now. You're everywhere. Can't get rid of the guy. He's on every platform. Yeah, I guess malicious users will be quite a thing with multiple windows open, right? That's going to be a thing. I don't know. If we get a bad actor, they could just flip over to YouTube. We don't get people like that here, so that's all well and good. Excuse the hiccups. I just ate a sandwich. Let's see. Boop, boop, boop. That's all good. We got this stuff here. I'm doing OTT for music over here on Twitch. Let's see. What else do we have going on? Not a lot. I mean, you know, like, took a break, made some spaghetti, and slept, and then came back, and now it's time to hit this microcontroller again with code until we finally get it working again. So I don't know if I'll probably start in a couple minutes because I don't have much else to do. We just need to get this thing running so I can get back to other projects. I need to get this VCO working, and then we'll when we need to pivot into another project in like a week or so, we'll do the VCO, the chord VCO, because that's going to be another session of programming. We know the hardware will work. If I put all the hardware together on this board, there shouldn't be any more mistakes than the ones that we've already identified. I do need to get potentiometers. I need to order a couple potentiometers, but then we'll have to build up this board before I order new circuit boards. That's part of the process. You know, I cannot just go ahead and order boards, because then when I build this, there's liable to be a mistake on it, right? In spite of all of the software's checking for mistakes, its amazing ability to go into your design and have all these rules associated with how things are laid out in order to keep you from making tons of like mistakes. Like the board that I made when I was like a teenager, where I had a trace on the wrong layer, and that ended up putting a trace like straight across a whole bunch of connections on the other side, because I had one side vertical and the other side horizontal. So one of my horizontal traces ended up on the vertical side of the board. That can't happen anymore, just because of the way the knowledge that the CAD program has of what the design layout should be. It says there should be a trace between here and here that's uninterrupted, and I will help you avoid stuff with that trace. Like, that wouldn't have happened on a modern design because of the software. The software's gotten so much better. But there still might be something. There still could be some kind of a tiny little mistake somewhere in the board. So we have to build this up into a working circuit. I don't have enough parts to do that. I don't have the potentiometers. So I need to go ahead and order them. I need to look at my DigiKey order history and order more of the whatever brand they are. What brand are they? And then we need to get into Node-RED. In the meantime, we need to get into Node-RED and actually make it work. Figure out how the hell to make that work so that we can we can affect signals in my local intranet and control all of the devices appropriately and set off farts. Means reprogramming that thing too. That'll just be like an HTTPS request or whatever. We could just retool the code that brings this thing up onto Twitch and just have it sit on the network and listen. All right, let's get to it. Do it to it. Slightly better location for that. There we go. The old fart box. Yeah, I guess it is old at this point. We built that we built that before. Was it before? Yeah, it was before I even started uploading streams. It was like pre-pandemic, wasn't it? Man, can't believe how long ago that was. And I've been streaming 3 times a week since. Get a glass of water over here. Yeah, I've been going strong for a long time. People thought my channel would pop off, and I guess it never did. We've always been kind of a slow grow kind of situation. We're a grower, not a shower here on Oh Bother. Put my pins away. Part of it is a promotional thing. I mean, I've only just started to get on YouTube, trying to make an actual presence there. Maybe we can get a couple viewers, some like-minded, maker-style individuals. Get the scope out of there. Bop. Okay, I guess I'm pretty much ready to go. What's the stat? Oh, the camera's, of course, loose. It's always loose. Do a little bit of that, torque it down. Really, you found this because of YouTube? Ah, there we go. Yeah, it I think uploading a 5-hour video every day is a little bit much for the audience. I get like 30 views on videos max. Some of them have gotten like a couple hundred views, and I think that was the YouTube algorithm going, hey, wait a second, this guy's doing daily uploads, which is pretty powerful. But in terms of like oversaturation, like if somebody likes watching my streams, there's not going to be a lot of numbers there because they're 5 hours long. It's a 5-hour video. Like, who's going to watch that? So I think I'm going to get more traction once I'm done all of these infernal uploads. Like, I get that back catalog logged in. I found you because of Burn the Subs. That's the other one is, you know, we gotta work on this a bit more. We gotta get that running. I gotta finish hardware on it, which is just a push, a couple wiring harnesses. But once I get all those YouTube videos up, I will then go back through and edit a couple poignant ones and make a few videos. I gotta get into the habit of making videos. I'm not a great editor. I did the one like Burn the Subs video, and then the follow-up, there was supposed to be a third, but it became too much of a thing. Editing is, you can be too much of a perfectionist when editing, and that's kind of where I am. I need to learn to kick back and throw a couple clips in there, a couple funny moments, and then voice over the whole thing. I could do like a very simple style video and then crank those out. Crank them out. Get like 20 videos done or something like that. But I gotta figure out what the sources of all my stuff is gonna be, like sound and all that fun stuff that you gotta wrangle up. You gotta make a fun to watch video. I think I could do that. I am more of a product of my environment in that sense. I have learned the goldfish has grown into the YouTube shaped bowl, not the Twitch shaped bowl, not the YouTube shaped bowl. We do need to update the fart box too. I'm endlessly jealous of Uo's lab, Uo Slab, because he does stuff really punchy and entertaining. They're not as complex as the projects that I do, but the projects I do are fucking boring. They're kind of boring. Having a VCO is a great thing, and learning to do VCO math has been an interesting thing, but like, it's boring. It's kind of boring. Maybe not, but it's less exciting than explosions and sparks. which I can't really provide you guys with because I will end up either getting injured or harming expensive healthcare products in the process. So can't quite live up to that one. Why are there so many PCBs all over the place? Probably because I ordered 10 of these friggin' things. I should have just gotten a couple of them. I don't know why I went for 10. I went for 10 and now I've got 10 useless circuit boards, huh? I should like staple them to things or make them into RC cars or something. How would I do that? I would need to attach a front and a back axle here and here, and then I could do the motor and the battery. It'd be like, I don't know where I'd get the differential from, probably Mini Z. But like this and maybe one of these could do. Actually, I could make a pan car out of these. We do like the battery and the motor. And then you'd have the axle in the front and the back. How's that measure up, actually? That'd be a really weird project to do. It'd be kind of funny, though. It's almost there. It's almost there. You know, if I do like one of those floaty back axles, I could do that, and then the back axle would be its own thing. And then it would be front wheel drive, or sorry, rear wheel drive. That'd be kind of interesting. That'd be kind of funny. Just turn an old circuit board with a mistake into an actual RC car. It'd require a lot of equipment though. I have to figure that one out. Could use an RP2040 on it. I got a new motor for this thing, by the way. I got a, it's a 7500 kW motor, which is still super scary fast, and if I jerk it around too much, if I'm steering too much and accelerating and going into reverse too much, it'll actually spike down the battery. The battery can't quite handle it still. I think the 5500, the one that Short Lurker suggested, is a happy medium between the super duper powerful and the slightly unpowered 2500. The 2500 was really good for indoor, like running around. Outdoor, I was trying to strike a balance. I think this is still a little bit too much. I still have to test this outside. I still have to be a giant man baby and go outside and play with my RC car on the street to figure out whether or not this is actually a good speed or not. I think the one down from this, I think Short Lurker was correct. I just didn't want to listen to him. So I ended up spending $30 when I shouldn't have. It's a pretty nice little RC car. I can say that now because I know what a really nice RC car is like. And this thing, you get it as a kit. It's got 1,000 parts that are smaller than you can fathom. It's difficult to build. It needs tweezers and a magnifying glass. When you put it all together, it makes a pretty nice, pretty robust little RC car. This thing is quite spirited and accurate and fun, but you're driving around a small fortune in parts and kit. So I had to make it my own. I had to take the circuit boards and put them on a 3D printed crossbeam that was designed after the original crossbeam. So this thing has 3 differentials going for it, and it's got a nice motor, and it doesn't have a censored motor. Those have yet to really saturate the market. When they do, having a censored motor means that you have much better control over the low speeds of the motor. This song is very distracting to talk over. This is a very distracting song to talk over. Does it get better? No, we're just going to the next one. A little better. Take the edge off of that a little bit, turn it down. But yeah, it's interesting to compare this one to the WL Toys. I mean, that's why I did it. That's why I did it. That's why I spent stream money on it. And now I know that like the WL Toys really can hold its own. You just really need to get into it. You need to take the whole thing apart and get off all the plastic flashing, possibly throw some graphite into a few joints to get it to properly do its thing, and absolutely 3D print a front bumper, because otherwise you're going to tear off the open wheel stalks of the RC. It's quite bad to smash. The first thing that I did with the WL Toys was crash it into the side of a table, and it sheared off one of the top beam things, the little Heim joints or whatever, the ball joints at the top. So definitely print out one of these things. The thing is, the WL Toys kit comes with one, right? It's got a little foam bumper in the front, but it's not big enough to cover the wheels. You really want something that will bump into a corner of something before your wheel does. And I still have yet to break this thing. I have to figure out where is this thing going to break? I have no idea. So far, I have hit a curb with it in various ways, and it hasn't exploded itself. And I've got a low enough center of gravity on all my stuff so that if this thing tumbles, it won't shear off stuff. The WL Toys kit, I put a shock in the top, in the middle, so that if one wheel bumps, it'll push down the other wheel. And that was apparently the thing that sheared off when it flipped over at a billion miles an hour, because the motor is irresponsibly powerful. Is it repairable? Yeah, all these kit cars, these RC kit cars, they have a plethora of replacement parts that you can buy. So I will absolutely be able to repair this when it explodes. But same with the WL Toys kit. They even have metal parts for some of the parts. They're metal upgrade, like spindles and stuff for this. What's up, Lawlin? Lawlone. How's the weight balances? I don't know about the weight balance in terms of side by side. There's actually on Thingiverse, you can find people have balancing like kits so that you can, metal RC cars must be really fun to assemble. I mean, look, the balance, but the metal parts for the WL Toys kit are terrible quality. You need to buy multiples of the kits and find the best of those kits. I've got tons of the parts. I can vouch for that. I've gotten too far into the WL Toys kit, to be honest, as a giant man baby. But I figure those small parts will come in handy for things we try to build that aren't RC cars. But in terms of like this thing, this was really fun to build. I had a great time. That was a wonderful stream where I didn't really have to think all that much. I probably should have lubricated everything as I was building it in terms of like graphite, because I actually went through one night and I took all the front and rear axle apart and I put graphite in all of the plastic to metal and plastic to plastic joints that this thing has. So I don't think it really did much. I don't think it's really a requirement, but it's a thing you can do. But yeah, all this stuff, it like the suspension is like consistent. It feels consistent. Everything stays in place. It doesn't wobble. This wobbles a little bit, but everything is very, very controlled and consistent on the expensive model. On the WL Toys, everything is a little bit rattly, and you can get over that. You can fix that. Graphite could be a problem with electronics, although it's in these two things, and I didn't use an excess of it. But if if you put too much in and it ends up dusting stuff, sure, that could probably be a problem for electronics. I don't see it being much of a problem with this, though. I wish DOS Micro would make a thinner speed controller like the like this one here. Let me go get the other one. The one that I got for $15 for 4 of them. It's actually a drone controller, but I would love it if this thing, and I'm not about to go learn STM32. What's up, Slime Swallower? God, I feel like I need to take a bath after saying your name. This thing right here was a $15 buy on Amazon. It's got an STM32 on it. It is programmable, but it has drone software in it. And the browser extension settings editing drone software doesn't have reverse. It doesn't have braking. It doesn't have all of the features that this one has. I would love to use this, though, because this can easily control these motors. And it would be a much sleeker design. It wouldn't have this big square right here. It would be awesome. Awesome. Love how streamers react to it. Yeah. I could go for some slime right now. Gross. All right. I'm pontificating about my RC car experience so that these are business write-offs, even though business write-offs don't really do me all that good this tax season. I guess I'm not doing quarterly statements, so my business is not really thriving. It's just individual income at this point, but it's terrible. Anyway, I would have loved to pop off on Twitch. That would have been neat. And then I would actually declare myself, I am a business, I declare business. And then I would have to do quarterly tax statements. It would be annoying, but it would be kind of welcome if I made enough money. Anyway, I ended up making the expense demon of buying a $200 RC car kit. And I'm talking about it right now just for funsies at the beginning of a stream. I've got the nice servo that I bought because I got way too into the WL Toys kit, and then these like Fly Sky, whatever they are, these 3-phase motors. These things are handy dandy for RC cars. I mean, I used to do like drone stuff, and I never ended up flying the drones anywhere, and I never ended up learning how to fly the drones or tuning the drones properly, and they ended up just being a big amount of work. And I've always, you know, the 10-year-old in me, I got that dog in me, I got that 10-year-old in me saying, hey, cars are cool, why don't you do RC cars? So I'm giving it a go. We've got 11mm wheels on this right now, which are more for keeping the car on the road, and nice soft tires too. These things were like $10. But yeah, this thing is all primed and ready to go, and I just need to take it outside and play with it a little bit and see what it's like on the road. Since we have a dog, I'd rather walk the dog, so I've been doing that more than I've been, you know, going out with the RC car. But anyway, yeah, these things, if I learned how to totally reprogram the STM32, which would be more microcontroller nonsense, we could make this into a pretty nice motor controller. Non-censored. If DOS Micro did a censored controller, I'd be very tempted to buy one of the censored motors, because knowing where all of those magnetic fluxes are is really good for slow speed. So slow speed consistency on the motors, and slow speed is really good for controlling something like this, as I've learned. I could tape a pointy stick to it and let chat control it, but even the slow speeds on the 2500 kV motor is way too fast, and this thing has so much grip on a smooth surface, it still ends up sliding out on a smooth surface, but these wheels have too much grip compared to the tank, so I wouldn't want to put a pointy stick on it. We did that a long time ago, and it was great, and if I did more stuff like that, I'd probably be more injured. That's the thing that I'm like you know, I'm careful, maybe to a bit of a fault. I'm careful. I don't want to get injured and not be able to stream, you know? So when I put that knife on the tank so long ago, that was like the second or third Rabaz raid that I've ever had, and I put an X-Acto knife on a little chat-controlled tank, but the chat-controlled tank didn't have any grip on my surface. So it did actually poke me at one point in a knuckle, which is a terrible place to get an injury. It went up and the knife blade went boop, but nothing happened. It didn't even break skin because it didn't have any grip on the surface. That was back when Twitch had alternate chat rooms, and so I had an alternate chat room that was dedicated to controlling the tank. And so it was just a flurry of up, down, left, right commands. Or forward, backwards, whatever commands I set out the bot to look for in the chat. And yeah, that was a lot of fun. It worked pretty well. I always say, like, if I had a house with a yard, if I actually had a yard that was fenced in or not, I would set a geo fence around it and then build something like big. Build like a big treaded robot that chat could control and move around. I was thinking about printing out a spoiler for this thing. I really should have put this part on a photocopier. Here's a word of advice. For those of you that know Fusion 360, if you buy something like an RC car kit, put all of the flat parts on a photocopier and take a photocopy of them. And those can be dimensional helpers for actually building stuff in CAD. I don't know if I got it in me to CAD model the entire kit. It does look like, you know, the SZ2, it does look like they did use Fusion 360 to build the whole thing. I don't know if they did or not. Yeah, chat, I wouldn't want to give chat a blade. You can really see how bloodthirsty Twitch viewers are with things like robots that they can control, because they really want to hurt you. It's their entire goal. People were foaming at the mouth, champing at the bit even, to try to injure me with my own knife tank. I mean, it's not like I didn't help them by taping a knife to it. You know, the implication is there that you're supposed to try to injure the streamer. Problem is, there's still something that's holding this up. If you look at this, it will, right there, oh, it'll get stuck. I guess it's not as pronounced when I do that wheel. Right there. So now these wheels don't want to move anymore. Right there, you see how it goes backwards? And then the rears aren't moving at all? That's because the pinion is getting stuck right here. So I need to open this up again and figure out where the spacers are going. I thought I fixed it, but it's still binding. There it spins okay. Ah, it's spinning fully. Is it dependent on gravity? It's not getting stuck. It depends on what the gearing is up to. Maybe if I push on the differential. Well, the thing is, like, having like something that rolls around your yard, I would definitely give it like geofences that it couldn't go beyond. So you would keep it in the yard. Twitch chat would obviously try to destroy it. I mean, that's the whole point. They would try to break it. So maybe you give them, like, without telling them, you give them an area where they can actually go and break the robot, you know, knock it over or whatever. And then you would be tasked with going outside and flipping it back over. But I mean, that would be an interesting always-on stream. Is just have this thing in your backyard that's running around. In terms of giving, you probably have to replace the batteries too all the time. But and then God forbid an animal makes its way onto your yard, right? They would be in instant jeopardy. Instant jeopardy. Why is my bitrate in the red? That's 5.9, man. This computer probably needs a different Ethernet cable, because it's all my networking equipment should be up to speed. I just haven't run new cables yet. Yeah, so anyway, this thing is a lot of fun. I don't live near an RC car track that I know of. I probably could look it up and see if I'm anywhere near an RC car track. I don't know if I want to go to one. I'm a huge fat guy, and I don't know if I want to go to that. You know, I gotta lose some weight. I don't have time for that either with all the projects that we work on here. So for now, this thing is just blasting outdoors. Don't think the house would survive. How? Well, what do you mean? Oh yeah, one of the 6-axis robots. I've already been saying that one of the 6-axis robots is that's how I die. That's how I die. Because I mean, we are gonna get into axes and robots once Burn the Subs comes back. When that comes back, and I don't mean the one we're currently working on, I mean the next one, I'm going to get into robot arms. But it's going to be DIY, 3D printed, smaller, like desk-sized robots. You know, I've looked on like the auction websites and stuff like that, and eBay, and you can find big robot arms out there. And I'm like, ooh, I want to get a big robot arm. But I'm like, no, I don't, because they're unfettered. Like, they will destroy you. They will crumple you up like a piece of tinfoil. And not even care. It won't even slow them down. Yeah, I definitely would die from a robot arm. One of my favorite ideas for a stream would be Twitch cooks you breakfast, and you have like a kitchen set in a warehouse. You know, you'd have a kitchen set, and then you'd have the 6-axis robot in the middle where it just couldn't reach you, and you'd be sitting there with a newspaper and like a table in front of you, and the 6-axis robot would have access to all kinds of, like, you know, cutlery and spatulas, maybe not knives, but then would have to cook a meal, but it would end up destroying the entire kitchen and turning it into rubble. Did a certification course for a rather small one. When going full speed, it's really scary to be close. Yeah, I would imagine. I've never worked with big robot arms, though. Never worked with them. Unless you have... I would assume that nowadays the better ones have like a torque lockout, because I saw, what was it? That was a Smarter Everyday video where they had bead forming of metal, and they had 2 robot arms that would fight each other in order to bead form a sheet of metal in between them in order to make a continuous like bead rolled form. And it was like 3D printing, but instead you have a flat piece of metal and it gets distorted out into your object. Yeah, that was crazy. Yeah, it's a really wild product. It's very interesting. So these robot arms have all kinds of sensors all over them too. So they know, you know, all the forces and where they need to be and how it needs to contort in order to get the results that it needs to get. Very advanced stuff. But I would assume that they know exactly the forces that they're going to deal with, and if stuff goes out of spec, they probably go, well, blah, 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 that's a fault, and stop. So, you know, while it's gouging out your eyes, it'll be like, wait a minute, I'm not supposed to be gouging out eyes, and stop itself. Maybe. I would assume the old... Well, I've seen accidents with the older ones, and I know that they are quite incredibly dangerous. But we're going to build a pithy little plastic toy robot arm that'll have a laser on it. Yeah, this thing has been cool. I've been really happy with it so far. I'm thinking about whether or not I want to print a spoiler. I can't seem to find 1/24 bodies for... well, I think it's 98 millimeter, I think is what this one is. I can't find bodies for cars that I like, being either dumpy or... Because they're all like supercars. It's all like, ooh, Lamborghini. And it's like, I don't want a little Lamborghini. I want like a little Prius or a little... something stupid. Something real dumb. Like I got the Toyota one, but it's too sporty of a Toyota. I want like a beige 90s Toyota Camry. Just something so stupid. I like the Honda EV concept from a bunch of years ago was really cool, and that would have been nice to have, and then I could have put a little screen in the front. I think the wheelbase for this thing is too long for that, though. Tiny Lotta. There's a, one of the ones that I printed so many years ago. I 3D printed one of these bodies. It was from Thingiverse, and I think it's a... Oh, God, I think a Lancia? Which is okay. It's a little bit of a boxy sport car. I'm thinking about whether or not I want to try to print that again and make that into this, because that would be kind of cool. This thing is too. This thing should probably stay open frame, though. To be honest, it's too nice of a kit. I can't imagine, like, you watch the like RC car streams. There's a couple like RC car racing streams. A teapot mod. You and those teapots. I know, if there was a teapot racing league around here, I would absolutely be all about that. But I wouldn't spend this much money on a teapot. I would do that so bad. That would be so awesome. But so yeah, my dream is of getting all of my friends to buy RC cars and then having an idiot racing league here. Because you can do that with these. These are small enough that you can, if you've got a carpet and an open garage, you can have an entire racetrack right there. I would love to figure that out and figure out where one could be. But my friends are few and far between these days. They all have kids, so they don't have time for frivolous things like this until the kids grow up. Maybe I'm just preparing for that. Oh no, Uncle Jesse's here to school us in being a racist. I mean, racing cars around an indoor track. He's so stupid and childish. Keeps binding. There's a bind point that this thing gets to right there. Yeah, get the kids and then the race. That's what I'm pontificating about. That's my scheme right now. What is... Ooh, that's bad. I think that's the front skipping. Is the front spinning? Ooh, it's like a gear... It's a gear kind of feel to it. What it should be is just the diff doing its job. Or if I lock both of these down. Yeah, now it's just the diff doing the job. But before it was the pinion gear skipping on the differential in the front. Not good. I gotta get to the bottom of that at some point. All right, I'm gonna put this aside and stop stroking myself to RC cars. That's been a very fun journey getting to that point with that. I got kind of annoyed at the WL Toys kit and ended up buying a really expensive RC car kit because it's nice and I wanted to figure out what the other end of the spectrum of RC cars is, because the WL Toys, I bought it specifically because it was cheap and then I got way too into it. We have a full 3D design of the whole thing. But yeah, it's just been an interesting journey buying an actual RC car frame and building it up. And I know I'm going to get my money's worth out of that thing because I'll be racing it around for a long time. But I don't know. For me, the building of this stuff is more fun. I end up spending all my time doing that. Speaking of which, we're working on a voltage-controlled oscillator for my synthesizer that I build and never use. There it is. It's covered in Burn the Subs. And my seed growing kit that I need to get into in a minute. Well, probably tomorrow. I'm not going to stream that though. I'm just going to plant it and set it up. That's my introduction back into Node-RED, is figuring out how to get the day-night timer to turn on and off an outlet. Yeah, my project is buried under all of the other projects that we need to do, like the steering wheel, using the steering wheel for car games. which I would like to do. I don't have time this weekend. There's also family stuff that I have to attend to. I have to tend to my father and his surgery that's going to happen in like a week. He'll be fine. They treat it like an outpatient procedure, but it's still a thing that you know, I gotta be on call for and help him with. So next week, I'm not sure what the streaming schedule is going to be. So there's going to be a couple absentees from Bother. He's not dead. Nobody's dying. We'll be fine. But yeah, in the meantime, I would like to actually get a project, like another notch on my belt for this fucking project, and actually get something done. And my synthesizer is lacking a voice. I have one VCO, and that's the one that's covered in tubes right now. I have one VCO. I want to have a bunch of VCOs. I hope there's like I can make a bunch of notes. Hope everything goes well. It should. He's actually getting. Speaking of which, this actually ties into the what we were talking about ahead of stream. He's getting robot surgery. He's actually going to be. I don't know if it's the Da Vinci machine. The Da Vinci is the I think the UPenn robot. I don't know. There must be multiple, but he is getting robot surgery, so that's pretty cool. They can make a tiny little incision and do all this work and pull all your guts out. It's pretty. They can do surgery on a grape too, and if you can cut into a grape, you can cut into a man. But it's yeah, so that's going to be pretty cool. How much VCO is enough VCO? No. That's the only answer that I can think of. So we've been working on this VCO. This design is a, it's gonna origami fold his guts. This is the VCO that we built. It uses an RP2040. The cool thing about the RP2040 is we have that Raspberry Pi chip on it that runs at 133 megahertz. So it's a screaming fast chip. And the RP2040 being small in stature and price, it's only like $5 a pop. It also has 4 analog inputs. So what we can do is we can program this little 3.3 volt chip to output PWM, and we can take direct control of the PWM, and we can put that into what's called a Sallen key low pass filter. So if we're hitting it with a high frequency of PWM, the Sallen key works a bit like, I describe it as Flappy Bird. So in order to trace out where your voltages are going, you give it little pokes of energy. So it's like tapping the screen on Flappy Bird, and it pops it up and up and up and up, and then it discharges and discharges and discharges, and you use that in order to recreate your frequencies. And it does that with microcontroller math. Microcontroller math kind of sucks. There's like weird laws that the math runs. I mean, you have to realize that what happens inside of a microcontroller is not you sitting down with an equation and working it out. What it does is it moves ones and zeros around, right? It moves ones and zeros around, and it does bitwise operations in order to perform mathematical functions. Sometimes there's more well, there's always a lot more complication to it than that, but you got to realize when we're doing math, it is within the bounds of a physical system that moves ones and zeros around. So when you have a microcontroller and you tell it, hey, divide by this number, it goes, wait, that's a rounded integer. This one is a float that has 2 decimals on it. And then it just does something, right? And sometimes it'll violate like order of operations and things like that. Can RP2040s do assembly? I would assume that any microcontroller could do assembly. Am I going to do assembly on it? No. No, you should not. Never. No. Nothing is worth it. The RP2040 does do MicroPython, and it does Arduino, and it does all kinds of different flavors of code. It's actually a pretty nice little system. So we got a core for the RP2040, and this design is a mix-up between a mashup, a mix-up, a combination of 2 different designs. One of the designs is from Hajiwo, who made the original $9 VCO with an RP2040, and we started to put that together on perforated prototyping board, and I immediately gave up because nowadays perforated prototyping board skills are apparently obsolete. They're only useful for vetting out your regular circuit board to make sure there are no mistakes. All those little wire things that you do with perforated prototyping board is completely pointless. Unless you want to build a one-off that day, you spend a couple days putting together a full schematic and then a full PCB, and you can just get 5 of them for $5 these days. It's crazy. It's crazy out there. It really is wild. And so we tried that with this, and there's like 3 or 4 mistakes on it that made it inoperable. We repaired the mistakes, and now we're getting the code to fully work, before moving on to the chord VCO. And we'll work on burn the subs, of course. We're not going to immediately do the chord VCO. But the chord VCO has the same mistakes that this one has. So we know where to repair it, and we can put that together and get that running too. And then I'll know that both of my PCBs are all vetted out and ready to order again. And then we'll be able to build multiples of these things, and I can give Julian and Dave them as well, and then figure out what they do with them, because I think they will do some cool stuff with a chord VCO too. Yeah, but anyway, so we're working on code from Hajiwo, and then Emilia Gillette of Mutable Instruments made a wonderful, and it's probably pretty standard, to be honest. I think a lot of different modular synth people are probably using these same circuit structures, but we copied the Salon key bandpass filter as well as the input scaling methodology of Mutable Instruments, which involves a negative 10 volt source chip. And so that works brilliantly, and it protects our fragile 3 volt microcontroller from being blowed up by 10 volt signals from a synthesizer. So hopefully in the future we have a CV and we have a 1 volt per octave input into the microcontroller, and we have an audio out. And so those three things, as well as the knobs, those things can then be used to make a filter. I'm hoping all kinds of different stuff. I'm hoping we can do all kinds of cool stuff with this, just this one platform, because it would be cool to have sort of a universal module that I can make it at different modules. And it all uses the RP2040, which is a pretty fast microcontroller. So we've been ironing out Hajiwo's code. Hajiwo's code is sort of thrown together because he makes like a new module every, I don't know, month or two, and he just keeps doing it, right? He just keeps making these modules. And so when it comes to coding them, the code is not initially readable very much, and it's sort of all thrown together. I mean, I guess it works. You know, it makes a functional module quickly, but in terms of our own comprehension of what the hell's going on, it's lacking. So we've spent the time to rewrite a significant portion of the code and sort of retool how it's functioning, and hopefully make it a little bit more versatile. And on the journey, the microcontroller was the friends we made along the way. On the journey, we hopefully learn a little bit about how this thing works. We're in the middle of that. Actually, we're at the end of that. We're close to the end of that. Things aren't quite happening the way they're supposed to happen, and it's the numbers. The numbers are all kind of flying into each other and not really working all that well. I don't know how Hajiwo got his code to actually function, because ours doesn't. Ours isn't quite functioning right, and maybe it's some of the stuff I'm doing, but for the most part, we didn't really touch the functional parts of how things are being sort of calculated. So we need to get into the code, and we need to look at what the numbers are that are coming back at us. So let's do it. No, that's not the right. Why do I keep clicking on the wrong stuff? First of all, power. Beep. All right, there's that. What is going on back there? What is this? Ah, those are our PWM. And I guess this is at a neutral position right now, which keeps our thing just test-driven development. I guess so. This is, I mean, yeah, that kind of works. So this is AM modulation. No, this is FM modulation. So FM modulation works to a degree. Mod doesn't seem to do anything, and the frequency is still adjustable. But our frequency range is a little bit weird. Our frequency range goes from 555 to 850. That's not good. That's not a good range. So the question is, I mean, what if I take volt per octave, V per oct, and I put it in here, and this is at 3 volts. That should be 3 octaves. And actually, I'm on the middle octave. Here's high frequency, middle frequency, low frequency. I think it might have the opposite effect. 2 volts, 1 volt. Yeah, less voltage is giving us more. It should be the opposite way around. There's our full... That should be a negative voltage and not a positive voltage, right? But this is as low as we go. There we go. That's as low as we go. Whoa. Okay, there. Well, 35 hertz. That's pretty low. It's not exactly, not quite LFO. Because that's still going to be an audio wave. Yeah, see how that rolls in? So it's half of what the electrical socket sounds like. So that's pretty low. Is backseat coding enabled? Well, we're going to be looking at microcontroller math, so maybe. I could just plug a speaker into this, but I think what I'm going to do is just do the. This is easier. That ain't sound like nothing to me. It's probably there. It's just my speakers aren't giving it to me. So that's below audio. You can hear it. If I had a subwoofer hooked up, it would be able to display it. Because yeah, my dumpy little monitors on this computer are not showing that tone to me. But that's pretty low. How high can we go? Oops, I changed the waveform type. Wait, we got to go back to a normal waveform. And then this, I'm going to reverse. Reverse the polarity. "26 hertz? Wait, what are you talking about? We had much higher frequencies than that before. Whoa, wait a minute. What happened there? Yeah, there we go. This is as high as we go. 8 kilohertz. Yeah, shouldn't Twitch do that? I mean, I limit the frequencies, even on my voice. Although our low frequency cut, I'm actually boosting. What is that? 30 is actually in the middle of the cut for my microphone audio. So actually, we do have quite a bit of range. This is just a tuning knob, I guess. This is just so you can tune the frequency to be exactly what you need it to be. Where's my... Oh, I see. That only happens when I go into the 0 point of that. I don't want to go to the 0 point of that. 8 kilohertz is not our full? Well, now it's just doing... seemingly doing nothing. Oh no, there's a wave there. But that's still 24 hertz. Like, why is it so far? And I guess our CV is coming in backwards. I need to do something about that. Highest frequency we've got. Frequency knob all the way up. It's like the frequency knob isn't doing anything. I guess because the CV is taking over. Here's 0 volts. Oh, I see. Wait. 2, 3. See, it starts going to the low frequency again. I guess it can't quite handle it. Something weird is happening with the math. So that is 8 kilohertz. And does frequency knob do anything? Yes, it does. Okay, there we go. There's like a boundary issue that it runs into. So yeah, 7 to 8 kilohertz. So that's a pretty good range, 35 hertz to 8 kilohertz. Not bad. But we don't quite have control of it yet because the mod knob does nothing. Does nothing. And if I switch modulation types, we get one different wave, and then all the other ones seem to just kind of exist. They don't really do anything. That one, of course, nothing really works. Well, that kind of works. That's the AC modulation, so it's getting quieter and louder. Looking like that. And then switch modes, and we should be getting like a square wave and a sawtooth. We're just not getting that. I'm going to lower the frequency now. There you go, 1, and then we turn this down a little bit. Our frequency is significantly lower. All right, so what the heck's going on? Well, it's all in the code, and I don't have the code up anywhere, our framework code. I could put it up. I don't know if you guys would appreciate it or not. We're still looking at the individual modes and fixing the equations, and for the most part, fixing the equations involves putting a decimal number in some of these numbers so that the mod 2 wavetable doesn't end up being an integer. But mod 2 wavetable is an integer, isn't it? Or do we have that as float? That's an int. It's an integer because it's telling a PWM signal what its output is supposed to be. So integers are all that's appropriate for that. Yeah, it's AM modulated, so it's the amplitude is what's hitting it, I guess. I don't know exactly what the in terms of how the VCO is functioning. I guess it's modulating the amplitude back and forth. Okay, so mod 2 wavetable is an integer. And the way this code works is we come in here and we set our table. We get all of our external inputs and scale them and make them useful. And then we come in here and we put them through the table set command, which does waveform thingies. It does FM or it does AM. That's the order of the switch. So right now we are in AM mode, and our program gets routed to different functions. So the AM mode down here calculates what the mod knob is doing, and it does that by doing a little bit of a decimal calculation here. It kind of scales it down. Then, if we actually have changed the what do you call it? We've actually changed the type of waveform that's going to be used down here. We create a wavetable. So waveform modulation is creating a wavetable, and I've got default values in the program that will set the equations up. And so the equations are up here, at least for AM modulation. Here's the equation, and they're relatively simple. Some of them are modulating different types of waves. Those are actually down below. But for some reason, that part's not working. Anyway, we make the wavetable, and then that wavetable is applied to mod, which we got just a millisecond ago, and then it applies mod to the wavetable and does whatever sort of scaling it needs to do in order to make mod 2 wavetable. During all of this, as the PWM does its function, when it gets to the end of a PWM cycle, it's in X number of steps, 1024 steps until it gets to the end of a PWM cycle, and then it runs PWM on wrap automatically. So it'll automatically run that, so it'll clear the interrupt request. It'll then set F, and if F is greater than 255, it sets it back to 0. And then it integerizes F for some reason, and then plugs it into the value of mod 2 wavetable. For some reason, that's plus 511. I don't understand that. So it on that slice number, it gets whatever wavetable thing it needs, I guess. So as it iterates through the slice numbers, it'll get its data from mod 2 wavetable and create whatever that thing is. And we know that works because we're able to get a sine wave pretty cleanly. I mean, we've got a pretty nice AM modulated sine wave too. So the AM modulated sine wave, unfortunately though, we're not seeing saw or triangle or square. We just see a sine wave, which is a little odd. And also, we're not seeing anything happen here. This is not happening for some reason. For int is I, for I is 0 to 256, mod wavetable value of I is equal to the wavetable of I times mod. So we're multiplying it by that number, which is 1024 over 8. So 127. 0 to 127 is multiplying into this. Multiplying into this and creating our mod wavetable. And then this is supposed to mirror the values as you approach the limits. For some reason, it's not. For some reason, it's not. It just doesn't do that. I made this 8.0. Maybe I should upload this just so we know that this is the code we're running, so we can see whether or not this is actually happening. I'm looking at waveform modulation right now, and so far, what we get with waveform modulation is nothing. Now, there appears to be something happening. There are little tiny breaks in our waveform, so maybe it's way too high frequency. Why does that trigger reset itself? It doesn't remember your trigger settings. Yeah, this is what we're getting. That ain't right. It's just one single little blip. One blippus in the middle of all of this weirdness. Mod appears to be adjusting the blippus. The blurpy. That's frequency. Take that frequency down so we can see it a little better. What do the other modes do? Yeah, we have different things happening here. I think maybe what's happening is that we're running into the 6 value. We're running into the high, like the ends of what the wavetable is. Let's take a look at Hajiwo's code and see if we're doing the same stuff. So this is the note.com solder state is Hajiwo's like note thing. It's translated from Japanese. This code was put together very hastily, and it's probably effective for what he's doing, but for us, everything is a little bit different because we've rewritten the code. I mean, we've made it our own. So, Voct POW Power 2 frequency table. We're doing the same stuff. We've got the same numbers. I went through the derivation of our own equations, and it appears to be correct. The PWM cycle is high. I think what we're doing is because when we create that table, the same way that Hajiwo does, he punches the number 6, the maximum value, into all of the spillover values. So from 1230 to the overall, from 1230 to 2048, he's putting in the number 6, and that's what we did. But it appears as though, I mean, our sine wave frequencies work just fine, right? So that's all correct math. But it seems as though we're running into the number 6 here. Obviously, I can't confirm that. I'd have to put a serial print in there in order to figure out what the numbers actually are. So if we are doing wave folding, well, what mode are we in right now? Let's just check with the serial printout. Oh yeah, we're not plugged in. I need to plug in USB. Yeah, we got the full suite of working on microcontrollers here. We've got serial plugged in, we have all of our inputs and outputs in there, and we have serial prints that'll tell us what the state of some of these numbers are. So we actually have to get to the bottom of all these numbers and figure out what they're doing and how to make them do. And in doing so, we're probably gonna figure out that we want to do the math differently or something like that. Hopefully we don't, and I can just put this thing to bed. I just want to finish this project. Please, please, I just want to finish this project. I don't want no trouble, sir. I just want to finish this project. All right, so that thing's on I put that on a vise just to hold it still because there's that wire connection here for the PWM cycle. But yeah, this is currently what we're outputting. So, what do? Why not do? What do on serial? Oh, this thing is out of memory error. Okay, so I'm gonna save and close Arduino. I think it's had enough of my BS for the day. I need to close all my Arduino windows and release the serial port and all that stuff. So I'm just gonna close all the Arduino windows and not save anything. I saved our main code. There, be free. This one was the original Hajiwo code, so this is, you know, whatever. This is just a cut paste of this that gives us our more familiar Arduino syntax. Okay, so let's open up Arduino again. You know, everybody's suggesting AI. Even my OS had a pop-up this morning that said, hey, would you like to use whatever it is, Copilot AI? Here's an introduction to AI. And I'm like, no, I don't. I don't want that at all. I do not want that. I don't even want a new version of Arduino. I'm using an old one. Open recent. And RP2040 VCO, this was supposed to be a framework, and we ended up just making it our whole code. We made it our whole personality. And now, hey! Pitchy! Oh, what's going on here? Wait, that wasn't just Pitchy. It was Crockily. Gifted 10 subs. Why'd you do that? Thank you. Hey, that's awesome. I went to Camro, JJ Smashing Pumpkins, Pit G, The Mighty Pong, Rotten Journey 88, Professor EXP, Carhole. Hey, Carhole's here. Pikel, DJ Doey, it's DJ Doey, and Makad. Hey, you guys haven't seen Carhole, you guys should go see Carhole. Carhole does a lot of really cool stuff. A lot of My Summer Car. As somebody who's gotten here from, I believe, Flatulent Gonad. Hey, thank you so much. Yeah, Crawl Calais, thank you. I appreciate this very much. 10 gifted subs goes a long way these days. So yeah, we're trying to get to the bottom of this RP2040 based VCO, and so far it's doing some stuff. You know, it's doing some stuff, but we're in wave folding mode right now, and the waves just aren't folding. Nothing is happening. I mean, when I adjust this, things are happening. There is math going on, but something ain't right. So we just restarted Arduino because our serial port ran out of memory for some reason. So here's our status. So we're on waveform 0, and the mode switch is on mode 2, which is actually the literal one. So when we go down here to table setup, and I need to put a couple checks in here to make sure that, you know, like if mod doesn't change, don't make all new tables, because it's rewriting the tables every loop. So anyway, we're in case 2, which is waveform mode. So from waveform mode, we need to now pick out, those subs are still going through, aren't they? Damn. That was the last one. Crackly, thank you. Thank you, thank you, thank you. That was very much appreciated. That money will go directly into burn the subs, for sure. Error downloading Digistump. I guess my Digistump stuff is so out of date now. Anyway, we're in waveform mode, so that's this function right here, right? And so we need to figure out what happened. Our frequency is set to 5. There it goes up to 6 and 7. 5, 6, 7. And it seems like the lower we go, the more PWMs we get in the end. Mod is at, well, was at 64. So mod's at 64, frequency is at 5. Let's take those numbers. And we're in mode 0, which should be saw. So we go down to saw. Well, first of all, we calculate the mod, which is the mod knob, blah, 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 1023, over 8. So we're basically 0 to 127. I don't know why, you know, dividing by 8, we could just do 127. We don't need to do a division operation there. Although that will limit us. Oh, you know what? We divide because we want decimal values. We want those decimal values. Because constrain is going to go 0 to 1024, but then, yeah, we want it to. But it's weird. Like these work, like the synthesizer works with positive and negative numbers, and I feel like it should scale with positive and negative numbers. And then, you know, you can shift that over to 1024. I guess that's what we've done. But when you add them up like this and then you limit them, that means that the signal going in for both the knob and so the knob and the control voltage they're not properly fighting each other. This should go negative and positive and have a 0 point in the middle, because when this unplugs, it connects to ground. And that ground point is in the middle. It's like I unplug this. Look at that, we get more signal because there's a bit more mod going into it. Right now we're outputting -2 into there. It does appear to be almost doing the fold. It just does it very, very early on. Huh. I think we're running into a lack of, like, the waveform number is too big. So we go into saw, we get our mod value, right? So that's 0 to 127. Then we go to saw, and in saw, for int is I 0 to 256, wavetable of I is equal to I times 4 minus 512. We need to figure out where these numbers are coming from. Why is it 511 and 512? Why do we then add 512 to the location on the wavetable? Why are we multiplying everything by 511? What the hell is this? That's the problem that I'm having here. We have 256 values, and they can be what? Maybe we should look into the RPi 2040 PWM thing that we're using. Let's take a look at that real quick. RP 2040 PWM. Been looking more closely at PWM and the RP 2040 following basic users' requests, and it's really very, very powerful. One thing I haven't seen elsewhere is the ability to synchronize the PWM channel using the PWM enable register. This is totally unrelated to what we're doing. We're actually using a different program. Hey, Poopsie Doodle, did you break it yet? No, we're uncovering the layers of broken stuff. I don't know exactly what the derivation of the numbers are, and it turns out that we need to figure that out. You should put AI into a synthesizer. I'm sure somebody has done that already. People treat AI as the solution to all of the problems that nobody asked for a solution to. And so they are applying it to literally anything they can get their hands on. So in the event that somebody gets their hands on AI, they're more than likely they are going to be putting it into some kind of a synthesizer down the line. That's almost a guarantee. PWM.h, it's just called PWM.h. So RP 2040 PWM library, I guess, is what we're looking for. Arduino reference, RP 2040 PWM. Is this the right one? Those important features are purely hardware-based PWM channels supporting very high frequencies. Therefore, their executions are not blocked by bad-behaving functions or tasks. This important feature is absolutely necessary for mission-critical tasks. Still work even if other software functions are blocking it. Much more precise than other software. Yeah, it has 16-bit PWM. We're only using 10. I'm AI. I mean, I guess. You're not artificial, though. You're not even intelligent, so I don't even know where to put you on the map there. Hardware-based PWMs still work even if functions are blocking. Moreover, they're much more precise than software-based PWMs using ISR, millis, or micros. Yeah, it does seem to be that we're setting up like really nice interrupts and stuff. This isn't helping us at all. I don't want to know how to install it. I want to know how to use it. That's the overall language reference. Hey. Oh, read the documentation. There we go. That's what I was looking for. Hardware-based PWM channels on the RP 2040. Oh my God, there's a lot of stuff here. Pin frequency and duty cycle. Initialize the instance. Overview and the programmer model. Jeez. PWM instance equals new RP 2040 PWM. This might not be the same of what we're using. I don't think it is. It's similar though. Yeah, this is an Arduino-based RP 2040 synth. So this is from Hajiwo, who's a YouTuber that makes very cheap modular synthesizer stuff. We started to build exactly the Hajiwo circuit with some mutable instruments design principles sprinkled in. And so this is the result of my using perforated prototyping board and going, I'm not doing this, and then designing this in Fusion 360 and actually making both the RP 2040 VCO and then the Chord VCO. Now there's 4 mistakes on both of these boards. So at some point, what I'm gonna need to do is build up this one as well with the modifications to make sure that absolutely every square millimeter of this board functions properly. Part of that right now is dealing with the software. I thought this was going to be a lot easier, but we got caught up in it, and we're correcting errors in probably the math. I don't know if it was my jam or Hajiwo's jam, but something's jamming it up. This should be waveform reflecting, and what it is making just a couple little peaks with a PWM wave. Now, some of the other modes do work, like AM, that actually does work. Theoretically, I mean, if you saw it work, it would be really cool. You'd be able to see it working. You'd be like, hey, look at that, that's working. But you know, yeah, it's doing like an AM modulated sawtooth. It's actually functioning. But what we're looking at is the waveform folding, and for some reason, something is jogging that frequency way too up, way too high for the PWM values. I guess what it's doing is probably referencing the end of the table, which has been overwritten as a 6. And so it might be down to bit math, but you maybe want to continue learning how to program STM32s. Yeah, man, if I really wanted to, if I wanted to get into STM32s, I would love to use this cheap little drone controller and totally reprogram it so that it has RC car stuff in it instead of RC drone. But that would be a lot of coding for me to do. The STM32 seems like it's a really cool platform, but the mutable instrument stuff that I've done has really kind of burned me a little bit on it. I think this is a different library. Yeah. Duty cycle, frequency. So, all right, so maybe that's a wild goose chase. We're barking up the wrong tree. I'm gonna use other phraseology in that one. Wavetable of I times mod. The number mod currently is 77, 64. It goes from 70 and 60 to 127 because it's divided by 8. So 2 volts, if I take it to 3, that would be -3, 4, 5. That should be able to go below 64 then. Why is it not going below 64? Currently it's at 64 to 127, but this should be, we're giving it negative, oh no, we're giving it positive 5 volts. Oh, but that's going in the opposite direction, right? Oh, we're not even giving, no, wait a minute. That didn't change anything. Hold on a second. Oh, it's not plugged in. It's not plugged in. Hold on. So 64 would be the divided by 8 minimum number. Now if we give it voltage into the mod channel, that maxes it out at the max negative number. So that needs to be flipped. Aha! Progress. We got a little progress. So here it is at 0. It seems to have changed. Oh, well, that's AM. Wait, are we in the right modulation? Yeah, we are. What is that doing for a PWM? Yes, okay, something's happening. Wait, did we get rated? Oh, we did get rated. Hey, Flatulent Gonad rating the party 46 people. How you doing? How's everybody doing? Sorry, I didn't notice that at first because I actually made some progress. Well, we're wobulating in exactly the same way we were last time. I haven't even uploaded code yet. What are we working on? Well, this is about the 5th time that I've explained what I'm working on, so let me do it again. This is a VCO. It's a voltage-controlled oscillator. It is a component in a modular synthesizer, which is all of that garbage that you're looking at right now. This is my pile of projects. We've got the force feedback Mercedes steering wheel sitting over here, neglected. Meanwhile, on the VOD channel, I'm actually uploading all the VODs from this project, and boy howdy did we get into it with this thing. We got down to this thing's bones, and it works now, and I should be playing more My Summer Car with it, or Monbazo. But yeah, I'll do some gaming streams in the near future. There's just some IRL stuff that's going on that's gonna eat up my weekends. But yeah, hey, Flatulent Gonaders, you're looking at another makerspace where the absolutely insane person running the place is into cars and synthesizers and all kinds of other little expensive hobbies. I do this basically with Twitch as my co-pilot, sometimes even funding the projects. We actually got a gift sub today, a bunch of gift subs today. That was really nice. Anyway, my buddy Julian has been after me to build a synthesizer for nigh on 20 years, and I figured out that you can actually just buy the circuit boards, and the creators of these circuit boards are like, good luck, asshole, and you just have to build them on your own with your own chutzpah. And so I love that. I think that's an amazing thing to do because I am a little bit over just the hobbyist level. I'm kind of an expert in building stuff with electronics. So we ended up 3D printing front panels, giving them all kitschy names. This one's called Crimes because it's Crimes and Ornamentations. It uses a discontinued microcontroller that's impossible to find. And yeah, I ended up just kind of piecing this stuff together. Now, currently, the state of the synthesizer is I have one VCO, voltage-controlled oscillator. I have something to control the voltages, and I have something to make a hat and snare. And so what that ends up being is when I mix them all together, I end up making marching drums. That's it. That's all I can do. So I figure I need more VCOs. I need more voices behind my synthesizer. What I actually need are more filters, to be honest. I need lots and lots of filters. But this project comes from a YouTuber called Hajiwo, and Hajiwo makes cheap modular synthesizer stuff. The thing about modular synthesizers is they are expensive. So we began building. Are you making an actual auto steering wheel into a controller? I have done that. That is what I've done. Gonad was here for the whole thing. Flatulent Gonad, who everybody should go watch Gonad. And also palpitate your gonads. Make sure there isn't any lumps or anything on there. But the steering wheel that I built, this thing back here, that's going up on all the VODs right now. On my VOD channel, Oh Bother VOD, we've got all the steering wheel streams. What I did, many, many years ago, I played My Summer Car, and I said, man, this would be a lot easier to control if I had a steering wheel, and that brought me to the Open Wheel project, and then I discovered Granite Devices, and all the while I was going, man, I should get like real car parts. You could do some cool stuff with that. Well, it turns out you can both buy old car parts and like phased out industrial equipment all on eBay. So I got a steering wheel, I got BMW pedals, I still have an actual electronic shifter from a BMW, but I replaced that with a gated one. That's a 3D print from Thingiverse. We have a shifter that actually has a real shift knob, a Mercedes S-Class steering wheel that has digital controls, and an industrial motor. eBay pedals are 10 times as expensive in the USA. I know, I don't understand. Gonad, okay, so I'm talking to Gonad, and we're on the same page, and we're talking about the pedals, and he's like, I'll build them out of wood. And I'm like, you don't have to do that. Like, you could just buy, these pedals are like perfectly suited to turn into controllers for car stuff, and they're comfortable, and they're the real deal, and they're strong. Yeah, and he just goes on eBay, and he's like, oh, they're only 15 bucks. These are like 60. They're relatively new though. They're in nice shape, but man, how did you do that? The wooden ones are still good. He advocates. He says, lying through his teeth, through his filthy teeth. We actually had to reverse engineer the digital protocol on this wheel in order to get it to work, and then I used that same digital protocol for the shift position and the pedal. So it was a huge project. And then I didn't have enough buttons on the thing, right? So to get more buttons, you can buy a wireless wheel thing. And so it's a wireless like little doodad that you would wire your buttons to. Well, I decided that I needed more buttons, but I wasn't going to put a wireless wheel on this thing. So we reverse engineered the wireless wheel's serial protocol and faked being it, so that the base station would connect to the fake thing, and the fake thing would get all of its button positions from that bus network that we put together. Big, complicated project. Anyway, what we're working on today is some deep-level microcontroller math. Yeah, I drove thousands of miles of those. I know, but like, you know, getting the real deal, there's something special about it, right? Somebody bought a Renault, and they crashed it, and they tried to pull back together the pieces of their life, and it ended up in a reseller, and the reseller pulled these pedals out, wiped the blood off of them, and then sold them to you for 15 quid, and you put them under your desk. There's something magical about that, you have to admit. Yeah, I was saying, Flatulent, one of the gift subs from today actually went to Carhole. So Carhole has been lurking in here. So we have a voltage controlled oscillator. This is the voice of any given synthesizer. The cool thing about this is that it uses an RP2040, which is a Raspberry Pi microcontroller. It can take all kinds of different code languages on it, and it's a little development platform that just plugs into a perforated prototyping board. The way you get audio out of an RP2040 is not by directly outputting audio. What you do is you use a pulse width modulated signal. So this pulse width modulated signal is interrupted. Actually, it's not interrupted. It's given different lengths every cycle. And those different lengths every cycle represent a voltage level that you're trying to achieve from the previous voltage level. So as you're going along, you're playing this game of Flappy Bird with the voltage level, and you end up pretty precisely, I keep twiddling the wrong knob, you end up pretty precisely recreating a wave, and that's done with something called a Sallen-Key bandpass or low-pass filter, but we don't need to worry about that. What we have is voltage level signals coming into this thing being read digitally as analog inputs and turned and scaled into a pulse width modulated table of values. So that table of values, I don't know, something's going wrong with it, because we're supposed to be doing stuff and it's not happening properly. And I think part of it is that as we exist on a number line, things are coming in and getting scaled weird. More efficient in code or in power? I don't know. I actually don't know. I think there are some microcontrollers that can output audio, but you can get a DAC, digital to analog converter, a DAC chip. And the chip does actually something very similar in order to make its audio. So I don't know whether there are advantages to this scheme. What it does is it's allowing a chip that can do computation very quickly to make a wave. And it does it using these sort of background tasks, where the background task will go through 100, basically each one of these cycles is 1024 counts. It's a 1024 count table that it runs through, and when it's done, it runs this quick little routine that figures out what the next duty cycle is supposed to be. Duty. And this, like, you have to understand, this is happening. This wave that it's making is 1.1 kilohertz. It's creating a 1.1 kilohertz wave by calculating all of these values, and every cycle of the microcontroller remakes this table. It's wild. It's amazingly fast. I am going to try to lighten it up a little bit and make it not recalculate the table every single time, because right now the values that are coming into the microcontroller are not changing. So I don't know why it would have to calculate that table every single time. It's when you start messing around with it, then the values should be changed. But that's neither here nor there right now. What we're trying to do is get this thing to work. So we have a mode where it's supposed to be reflecting a waveform on the number line and reversing it. I think 35 kilohertz is what the PWM is. So we have a waveform reflecting mode that should do stuff, but it maxes out. See, it actually started, that actually looked like a reflected waveform just briefly. Yeah, right there. When mod is at 3 or 4, that actually looks like what we should be seeing. Mod is at 4, 3 or 4, and that's our end number for mod. Yeah, it's really quite notably fast even. So our mod is not being scaled properly for the equation. Okay, so what's our minimum mod? Where's everything untouched? Right there. So with mod at 0.75, if I keep going, does it go negative? No. But even at, this is at 0.25 and sometimes 0. So tweak it up just a little bit. Whoa, whoa, whoa. So that's mod value at 0.8. Yeah, hold on. Let's take a look at this though. So from 0.8, mod at 0.8. Yeah, we're doing more. I didn't want to focus on this for so long, but we do need to. We're trying to get that final push of everything working, which is becoming a little bit more of a disaster than I had hoped. It's getting to be a little bit unwieldy. We're doing this by affecting control of the control voltages. We're setting a control voltage to -5 volts, and that's apparently pushing this thing into the territory where it actually functions. So now we need to figure out what that maximum value is. You can see there it's reflecting the waves properly. It just gets a little squirrely about it. I don't know why it's so unwieldy. It's going 0.8 to 0.75 and 0.6. How do you know these numbers so well? Ben Gizmo has been actually crucial in helping me out with a lot of this stuff because he seems to understand, they seem to understand things very much more than I do. Wavefold mode, mod should be 0.9 to 4.58. Well, I think that's what I'm just discovering now. Yeah, because here it's at 6, and there's 4.5. So it should, yeah, it's like, how are you a page ahead of me at all times? You're just fucking good at this stuff. To 4 point, and it was the same thing that you had, right? 5.8. I have the wrong mod setting. Back to the Hajiwo code. How do you know all this stuff? It's like I'm still trying to understand how all the 511s are in there. Everything is multiplied by 511, and I don't understand it. So yeah, back to Hajiwo's code, and let's take a look at how Wavefold does its stuff. 0.36, 0.0036. Oh, divided by 8. This one's the 0.36 one. All right, so yeah, I definitely messed them up. So that's probably why AM doesn't quite work right either. Oops, I took the semicolon off of that. It's fine. So this one is the 0.36. And then let's look at the other modes. That's wave folding. Where is fold, FM, and AM? FM is divided by 8. Divided by 8 for FM. So that's wave folding. This one is AM, FM, and that's not 1023 minus. So that makes some sense. Maybe our code will actually work. Over 8.0. Gotta put those decimals in. The audio values are -512 to +511. So 511 is an amplitude. 511 is maximum of 8-bit when you count from 0. Oh, so that, yeah, that's the full spread, but that's centered on a number line. See, that's what I'm talking about with the knobs too, because they're not centered on a number line. They're taken as 0 to 1024, and then you add 2 of them together. It doesn't make any sense. If you took it on a number line, then you have an add and subtract from your knob. I would rather add to my knob, but that's a personal problem. So this one is 1024 minus for AM. Should that be 0.0? That doesn't seem like that'll ever go into that, but we might as well. Yeah, PWM says 0 to 1023, so the audio values of 511 added to them to translate -5 to 511 to 0 to 1023. But then the way that we're taking our knob in does not respect that. It's mod knob plus the mod CV. What the? Feels like that should be centered on a number line. Well, we'll just do it this way first because we're not generating the waves that we should be generating. So let's upload that, and then we'll figure out what that does. So I had my mods mixed up. Well, that makes sense to what we were looking at, because we were looking at the numbers and how they were coming in, and I used a control voltage in order to set this thing all the way down to dinosaur bones. I want some paddles. Oh, pedals like Gonad has. Yeah, he bought them on eBay. Like, this is what both Gonad and I did this. It just cost me 3 times more because my eBay sucks. Excuse me. Because, you know, everything's expensive now. But the pedals that are sitting all the way in the background there are actually from BMWs. And if you put up just like a block of wood and use some wood screws, you could utilize those pedals. Just put them under your desk. Like, it's actually kind of awesome. The throttle was the easiest part. The brake is the hardest part with those pedals. And what I did is I put an aluminum bar at the back of the pedals, and then I put a little load cell on there. That was expensive too. That was a $75 load cell. You can probably get cheaper ones now, but you put a load cell on it, and then you can have that translate out into voltages. So and then you, of course, you have the best tuned brakes in the world because there's absolutely no movement when you hit that brake pedal, which isn't exactly accurate, and it kind of threw me off. So what I did is I put a spring on it, and so now I'm pushing against that spring until they firm up. So then it feels like my real pedals, being a shitty station wagon and having the pedal move a little bit. Yeah, foam you can use too. My whole setup was about 40 pounds. Jeez. Yeah, if you guys, the people who didn't come in here from the raid, I know Groovy Something already knows who Flatulent Gonad is, but you guys owe him a follow. You guys should go check out Flatulent Gonad because he does with very little what I do. And he does it to just the same degree. His shifter is just wood with stuff cut into it. He's the big spring and a lump of foam for my brake. They feel good enough. They feel real enough. Yeah, I did it with all of this frickin' engineering. I put together 3D prints. I have a spring in there. I have a thing that specifically mounts to the BMW pedal. I like made sure everything was super nice and works great. And I've used it like 4 times maybe. So we'll need to do some driving streams. I'll have to do some driving streams. I was hoping I could lose a little bit of weight before I did another driving stream, though, because I look like this big fucking blueberry sitting on a chair. All right, so anyway, wave folding mode and all that junk. It seems we may have fixed it. I mixed up all the values. Dirt Rally stream. Didn't I do one? I think I did one. Come join us on BeamNG. That's what I've been saying. I should join you guys on BeamNG at some point. Let's get this up into the Raspberry Pi and see if that fixes all of our stuff. We now know more about the math on this thing than we ever wanted to. A combined stream event where we do like teams or something and we add each other in the titles. Yeah, good rally practice for my summer car because you can do the slew mode stuff and reset yourself. I feel like Dirt Rally's too frenetic for Gonad. He'll explode. What do we do? Oh, I forgot. We need to do this stuff. Doink. We got a doink there. And did we doink this? No, we don't doink that. We doink that. We doink that one. We doink that one. And then this one needs a doink as well. Nope, it has one. Okay, so that should sort everybody out. Not sure I can follow instructions for that long. I know, right? Why are you being so insistent? I want to go this way. Sammy, you're breaking the car. All right, code is uploading. I still haven't built the LED engine that I need to build. That's a little bit more boring. All we need to do is just look at timers. I need to set up a little timer and then do some timer math and all that BS. Because it'll just be an array, and each time it finishes a timer, it'll just move the array and change the LED state. So there will be 2 states. One will be on, the other will be off, and you give them both timers. Gonad knows does he know all the stuff that Grandma says, but translated correctly? I want the real translation of everything that Grandma says. There it is, scanning for the device, flashing F. Oh, error opening COM4, whoops. I can't have a serial open during that. Upload. Does somebody have a full, I'm sure some forum has done it already. Translate everything Grandma's saying. Or the people on the phone too. Because they're like, I need firewood. But they're talking for like 20 minutes. It's like this uninterrupted 2-minute long Finnish rant, and it's the translation below is just, I could use some firewood, and you're like, I don't think that's what you're saying, bro. All right, so here we are in mode 0. Let me open up the serial port so I know which one I'm in. Waveform 4, 5, 6, 7, 8, and that's waveform 0. Wave folding mode. Still broken. What if I unplug the control voltage? There we are, right in the middle. And so that can unfold it to a degree. It seems like something weird is happening though. So the maximum value, 4.58, and I bring it down and it goes to 2.76. And when I plug in my control voltage, it goes down to 0.9, which is valid. So that's 4.58. And now it's still at 4.58. And I can take this down to 0.9, or I could take the control voltage down to 0.9. Okay, look at that. We got our wave folding going on. Why was it blank before? Maybe something went into a weird value. And we have a little control over the frequency. This control of the frequency, because this is 1 volt per octave signal, this is a 1 volt per octave signal, so this is just used for tuning. So we don't get our maximum range from the knob. We get our maximum range from this right here, which is the voltage input. Okay, wave folding, at least on waveform number 1, appears to function. Look at that. So what if we go to waveform number 2? Of course, waveform number 1 is, okay, that's just, yeah, waveform number 1 is, let's look at waveform code over here. Well, that sure as hell doesn't look like a saw to me. Which one are we in? We are in, oh, we're in waveform 1, not 0. So waveform 1 is just a regular old sine wave. The next one should be a square wave. Hey, look at that, it's a square wave. Insofar as audio is concerned, it's not exactly the best square wave. What does that look like? Burp, 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 burp. Full duty cycle, half duty cycle. Look at how nasty that that square wave is. It's dirty as hell. I love it. What happens when you reflect a square wave, though? I don't think that's really going to do much. Oh, this is just modulates the square wave back and forth. Okay. Whoa, that's really nasty, though. And then, of course, this will just do tuning the frequency. Nice. Hey, we're taking a PWM signal. We're making a table of values for a PWM signal, and we're affecting its change over the cycles and creating an audio wave on the output. I think that's kind of special. So the next waveform is supposed to be a triangle. And it is. Ish. It's always ish. It's always ish. But yeah, each individual value there represents the voltage level that we're supposed to be at. And we're doing that with microcontroller math. Hey, Kervos, it seems like we've stumbled upon a victory lap stream. And there's the wave folding, and it just becomes a higher frequency triangle wave in the end. But this will sound pretty funky. I don't know about all the weirdness that's going on. We need to build in a couple things to our signal to make sure that it's not creating a new table every single cycle. Only want the microcontroller to do work when work is necessary, right? We have to look at the frequency values too, but we need to evaluate all these different waveforms. So the next one is oct saw. Oh, it's a weird saw. It's an octave saw. That just becomes triangle. Everything returns to crab. I mean, that looks a little more like a real saw. That's an actual sawtooth. That's a weird reversed one, too. Next is FM1. You have the bounce library in your code, so you're probably not table setting every time anyway. Well, no, okay, so every time I hit the button, it table sets. That's fine. But what I need it to do is check to see whether the mod values and the frequency values are the same from cycle to cycle, and not do the full table calculation if it because I don't want the microcontroller to be doing stuff when it doesn't need to do stuff. Soon to be music phenomenon, oh bother. I don't think I'm really going to be doing that. Waveform number 1. And these are the equations that Ben Gizmo put into that thingamajig. And it looks pretty cool. You have multiple reflections of the wave. Pretty cool. Yeah, it needs to have a previous value for each one of those variables. And that way I can just check against the previous value and not run the full thing. So this is waveform number 2. I don't know the difference. They look like the same thing. And then this one is FM3. FM3. They look the same. They look like the same thing. They look like the same thing. The derivation values are slightly different, and I assume they sound a little different. Yeah, we would need to plug it into a speaker, but I don't want to listen to the same tone for 5 hours. I may bring the speaker over in a minute, but okay, so that's that mode. That's wave folding. So now I really, you know, this thing could really use like a screen on it, just like a little screen on it somewhere that would show you the waveform. All we get is this LED to kind of give us LED and then listening to the sound. I know, we'll hear the wobulations in a minute, but next is FM. So this is frequency modulation. Mod is doing nothing. So what is that supposed to do? So in FM mode, or is it AM? No, we're in FM mode. FM mode, we get our modulation is given by a giant equation that involves the mod number, and the mod is being constrained. And again, actually, these are the equations that Ben Gizmo put into this thing here. Where did I put that? Oh, right here. And you guys can play around with this if you want. Here is the link. And we can see what our first waveform mode should look like as we go through the mod number, 0 to 128. Our mod number currently, oh, we're on waveform 7 too. Our mod number is 0.25, oh wait, that's frequency, whoops. 0.25 to 127, a little over 127. And we'll turn the waveform back to 0. But it's not doing anything. So something else is broke. Something else is broken. Currently on the middle setting, which should be FM modulation. And so that should... Apparently you gave us math homework. Yeah, right? I did what now? You put it into the thing. Didn't you do this? You linked me to this, right? Somebody did. Who did this? Huh. All right. So whatever this is doing, it's still putting in a sine wave and getting a result out. 1, 2, 3, and then that's whether to divide by 8. A1 are being plugged in. No more math homework. No, anything but. These directly make the mod 2 waveform. But this isn't really functioning. Even though it is giving us a sine wave though. So, I mean, something is happening. Sorry, I forget to scroll up for the equations. So this is a polynomial equation that I put together, and it should calculate out what that waveform looks like, and it should respond as this graph tells us. It should look like this when we turn up the knob. But it's not doing. There are no errors in the code, but there might be some weirdnesses in the code. Yeah, Krawkele has gifted 10 subs, and I'm super happy about that. That's very nice of you. Definitely thank them. So, mod of FM8 is 0. So we go to the else. Mod 2 wavetable is equal to sine 2.0 times m pi times I over 256. Put a 0.0 in there just to make sure. Plus mod A. And if mod A is not defined, it should start as a 0 due to the default values. So we come in here and we make all these variables 0. And so if mod A1 is not written, then this doesn't run, and we just do sine of 2m pi I 256 blah 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 blah, right? That all works. So if we do set mod A, we have to set a mod A1. Oh, wait. Oh, whoa, 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 whoa. We are not doing A1. This is just mod A. So this needs to be 1, 1, 1. And D and E also? Yeah, D and E also. Mod D1's already in there. Wait, is that the correct one to do? Hold on. Mod ABC, mod over 128, ABC. We're not doing any of the denominators. Okay, so that's what's messed up. So down here we have A, and A1 is the 256 term. Okay. That's the problem. So we have, where's my equations? Where did my thing go? Where did it go? There it is. This one is A or C1, B1, and A1. And then they're all 2.0, 256. All the way at the bottom here with my notes. Oh, and it's actually 128. Well, it's over mod 128, and then that one is not necessarily 256. This one is. This one is always 256. It's the mod that's 128. Can I identify as a polynomial? I'm an expression consisting of indeterminates. Sure. Yeah, I mean, you know, called people weirder. This is over 128. This is 256. That's 128. And these are our new coefficients that didn't go in before. Yeah, I'm doing D and E first to check to see if there's that thing at the end, because it would be sine of thing plus D and E. So mod D either gets assigned or it's set to 0. All right, let's check that one out. Let's upload that to our microcontroller and see if we can now effect change on these waveforms. Oh, do I have the serial port open? Not for long. Waiting for code. It's compiling. It takes forever. Did it lock up? What's going on? Oh, no, it's still working. Still working on our code. But what a Friday, huh? I think maybe after next week after next, I'll plug the wheel in again, and we'll get that rolling. I probably want to do a round of adjustments to the wheel too, so my big fat ass can actually use the pedals properly, because they do get a little bit tiring. I think I had them pretty well adjusted, but what a Friday indeed. Yeah, I know. No scope for what? Why one? Oh, I put C1, B1, and A1. It's mod of all that. Hold on, I gotta correct. Just write mod in these 3 spots. Yeah, I really want to use that wheel again. I've been uploading the gaming streams, and they do, on the VOD channel, they do a lot better than my normal VODs. Anything that shows like building a computer or like a Fusion 360 model, gets a lot more views. We can just see right now. Oh yeah, I have my favorite thumbnail ever. Not this one. This one's not a bad thumbnail. It's got my feet in it. It's got foot cam. Foot cam is now banned on Twitch. That one's a weird one. Oh yeah, there's the text for idiot. I don't know if this one works anymore. No, it still works. It's my favorite thumbnail. I need a haircut. That's another thing I haven't been able to figure out because I've been a total waste of space. Oh yeah, I should merge these down. Hold on, merge down. Merge down? Why is that blocked off? Oh, because it's not visible. Merge down. There we go. Twitch being weird about cameras being pointed at certain body parts. I should actually, the way that I should be streaming right now, because we're not allowed to show any intimate body parts on Twitch anymore. So, you know, we can't focus. Ah! Dear God. We can't focus the camera on any of it. So I need to actually get into my streaming garb here. And it's a very important set of equipment that I need to have in order to stream this kind of stuff to you on Twitch. We can't focus on body parts anymore. So here we go. So, all right, I hope this is good enough for you guys. We're not allowed to show anything. So I have to stream like this. We're not allowed to focus on any sort of intimate body parts, which include lips, fingers, feet. I'm sure there's something else in there too. Eyebrows are pretty intimate. So this is going to be it for me. I mean, we got to somehow do projects with this stuff. So let me get to the right scene. I can't actually see. Maybe we could use. Yeah, I got to go to the scenes thing on the Stream Deck because the Stream Deck buttons are big enough for me to actually get to. So this one would be the spring ears are intimate too, so I got to cover those. Let's see here. I can't really find all the scenes that I need to switch to. Where's the? There it is. Okay, there. All right, so we're working on this thing and we're trying to make sure that wave folding functions, and I can't show bare body parts, okay? So I gotta kind of make this work. I gotta make this work for me because we can't violate TOS. We're not allowed. Oh, this thing is slipping. Is a beard an intimate body part? Because I don't know how I'm gonna solder with all this stuff on it. I can't really see because this is a welding helmet, Okay, fine. That was the wrong scene. There we go. There we go. So yeah, sorry, you guys saw my face for just a second there. Twitch, please don't ban me for showing my face, because lips are an intimate body part, and I can't show those. So I don't know how I'm going to function like this. I guess the streamers that don't have face cam are in good shape. Well, the neck is an intimate part. I'm showing neck. Oh, Jesus Christ. Okay, we almost messed up pretty bad there, chat. We almost showed neck. And, Twitch is watching. All right, are we done with this bit? Can I be done with this bit now? Because I can't see a damn thing. I can't even switch scenes. Ugh. That's my welding helmet. Needs more googly eyes. I already did the monster face with the copper tape. That hasn't turned green yet. This welding helmet's been around for a long time. It's very dusty inside because it's been hanging on the wall. This is from Jalopnik. Back when Jalopnik was popular, they had somebody made a skull and drive shaft crossbones. So I am that much of a car nerd. I gave my welder to a friend of mine, and it turns out that I need it again because my car is rusting into a pile. Need a stereo mic to capture the Asmer wind tunnel. I don't know what you guys were hearing there, but it was all reflected on the welding helmet. All right, let me get these gloves off too. That's going to be kind of difficult. Oh, I've got to hang the welding helmet so it doesn't fall down and kill me later on. Maybe we'll put the welding helmet on the ground for now. Yeah, that'll go down there. Okay. These are making farting noises. Why are you talking about thermite? These are electrical gloves that came to me from some electrical guy who had a, like, either a free cycle or something like that. I should have put powder in these to begin with. These are not coming off. Yeah, my car is turning into a pile of rust. I need to undo the rust on it, and I watched a video on how to undo the rust, and it's kind of involved. Oh boy. You need to just do that. Just invert it. Look at my finger holes. Oh wait, I can't show that on Twitch. I'm gonna get fucking banned. Some Twitch staff member is gonna be like, what is this stream? Opens it up, and I'm sitting here showing all of my neck. Look at that. Disgusting. I have a camera that's just fixed on it. The scroll that makes you hear maniacal laughter. What? Some kind of wizardry going on here. Oh, look at my collapsed finger. That's pretty phallic. There we go. No, I don't think I've ever played that. I mean, roguelikes. But I know my fair share of RPGing. I feel like I have to put on the glove in order to get the glove back on. These need to go back in the bag that they came from. I need to get them back. It's a quick bit to employ, but it's a hard bit to put away. What kind of rust are we talking? There's like an outer layer on the unibody, and then there is a jack support that goes up into the frame, and basically it's like, because it's a unibody, you can buy a section of the body, but it's basically rust on the bottom, and then there's features that come into it, 3 features that come into it. So you have to you have to drill out all of the spot welds, remove the piece, and then put a new piece back in. It's not difficult, but it is involved. And I don't know, maybe I'll have to just get a body shop to do it or something. All right, I'll put the gloves back together later. Fucking things. Fucking thing sucks. You put Gold Bond on my hands in order to put these things on. And then a hand was born. Should make a robotic, make these have little robotic fingers. We could have a co-host. I couldn't press anything or operate anything with this on, though. All right, put this back in the corner. I'll put all that stuff back together later. Jeez. At least we didn't violate TOS. Okay, yeah, so we put in the new equations. And we are currently probably in mode 0. Let's check. Waveform 0. Our mode is at 0. 0 or 0.3, and if I increase it, nothing happens. That's 0 to 127. Take this out. That's 64 to 127. Now it's 0 all the way to 127. It does nothing. Frequency still does adjust frequency, but something is happening in here. So what if I take any of the waveforms? Waveform 1. Nothing. 2. Nothing. 3. Nothing. 4. 4 has a different wave to it, but it looks like it's only getting to that last coefficient. 5. Nothing. 6. Nothing. 7. Nothing. Back to 1. And this is in FM, and changing the octave doesn't do anything. Okay, 0 to 127 on these things, but we're not getting the behavior that is laid out in the graph. It should be wobulating differently as we charge up to 127. So what's happening? It's probably my restructuring of how this thing works. A, B, C, D, E are all set to 0. So if mode D has any value to it, and it doesn't, if we're running just the default values. This will have nothing in it. So for 0 to 256, if mode D is anything, do this calculation. If mode C is anything, do this, blah, 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 until we get all the way down here. And then it has to evaluate the else, the if else. If FM8 is set to anything, otherwise just do this. My code is what's full of eels right now, not the washing machine. I had to rip my machine apart a few weeks ago because a rubber band got wrapped around the impeller shaft. What? How does that even happen? Jammed up the ejector pump. Huh. Damn. It's not... Yeah, having a non-draining washing machine, that's tough. You got to siphon all the liquid out of it then to get to the bottom of it. All right, so I feel like it's not evaluating the equations. I feel like that's what's happening. I made all of those into floats. They've got their equations here. They, of course, are wrapped around one another. D and D1, EE1, mode, int mod A1 is equal to 0. Shouldn't affect it, because then it just won't run. ShopVac's another good way to do it, yeah. Wave table of I, 0 to 256. Mod CI, mod C1 is the denominator of that. These are directly out of the 2.0 sine blah blah blah. It feels to me like this isn't running. Why would it? It should run. I mean, that float of mod A, and then an int A1, float mod B, int mod B1, etc., etc. And then that creates how many things? Take the filter out, rinse the can first. What if I take the filter out and then upload that? Figure out if it behaves exactly the same way. My hands smell like the powder that was inside of those gloves. It smells like rubber. Don't forget to rinse your can. How would I do that in the micro? I don't know. That seems kind of complicated. Ooh, it's windy out there. Hey, Celia, how's it going? How you doing? How you doing? So yeah, this still does nothing. Frequency still does something. Changing modes is widely... Well, something happened there. What mode am I in? I'm in mode 7. What mode are we in? Oh, it didn't upload code. Wait a minute, that didn't upload. The COM port is in use. Let me upload again. Uploading again. Been playing Minecraft. I need to play a game. I haven't played games lately. I downloaded Outer Wilds. There we go. It took me a little while, and I was going to play a little bit of that, but I haven't gotten around to it. All right, we're uploaded. So now we look at, oops, wrong camera. Look at this, and we are in what mode? It should be the previous mode as determined by the EEPROM, but I don't think that's working. Mode 1, mode 2, mode 3, mode 4. So mode 4, I believe, is the one that does the divide by 8. Or the divide by 2, rather. Let's check. This is not the one that I'm looking for. There we go. 4 is... Yeah, this is the one that actually does the divide by 2. So why is dividing by 2 breaking it? mod A and mod D are actually, well, those are actually given values, aren't they? Although, oh, mod D doesn't have a scaled value, so that's probably what's going on here, is it's maxing it out because it's not, it's giving it junk data. So mod D is actually being given, not 256, being given the number 11, and I guess that's probably messing with it. Plus 11 is probably screwing that up, that sign coefficient. So, okay, so that, I mean, that makes a little bit of sense. Does mod do anything in this mode? No. So mode 5, still broken. 6 comes back, and then 7. Oops, I'm in a different one now. Waveform 0. I'll set that to 1, and then we're gonna enable more stuff, but yeah, I don't know what's going on with this. Mode A, mode A1, mode B, mode B, mode B1, mode C. They all have to be there, otherwise this thing doesn't function properly. Because otherwise it'll be punching numbers in where it shouldn't. Like this will become its original stated value instead of a 0. But something's happening to this, and I don't know what. Sine 2.0 MPi I 256 mode A plus mode D times 511, and mode D would be 0 by default if it's not declared. And of course you have to declare them in order, and they have to be present or not. So we 0 out these, and all of that should be fine. Boy, it really is windy. I'm listening to the wind out there. Wind's howling. Let's see. I mean, that by all means, this should just make the proper thing. I don't understand why it wouldn't. And then in the case of like, well, do I need zeros in these? Well, if I did, then case 4 and 5 should work, but they don't. I've re-enabled all these. Let's just upload this again, just to look at it again. The problem is these are being evaluated so quickly that if I did a serial print, it would just like destroy our screen. We wouldn't really be able to evaluate anything from that. Like if I print out the result from that equation, that's going to be a 256 round serial print. Oh, wait. Of course, I could blank out this whole thing and then just run FM modu and then put junk numbers into it and see what happens. All right, there's that. So what waveform does it say? If we're on waveform 0, then my EEPROM stuff doesn't work. Yeah, my EEPROM stuff doesn't work. I'll have to evaluate what the hell's going on with the EEPROM then. It might be that the RP2040 doesn't have one or has a different code. 2, 3, 4? Did I close the serial port? No, this is mode 3. So 4 and 5. 5 doesn't divide by 2. But this one has all of the coefficients in, and our mod number goes from 0 to 127, but it's not doing anything on the waveform. It does nothing. How is that the case? Is it my logic? Is it my logic up here? So if mod D, let's add it does not equal 0 to all of these. Because we're passing those values. Oops, I didn't highlight the 0. We might not be evaluating the expressions in any way due to a float. But a float, maybe 0.00 versus 0? I don't know. It doesn't make any sense to me. If FM8 does not equal... I did all this work to make everything line up, and then it's all over the place. 2.0 m pi I over 256 plus modular A and mod B, D rather, and if it doesn't equal 0, otherwise these will zero out. So those are just 0, and that's plus 0 and plus 0, so it doesn't affect the equation. When in doubt, more serial.print. If I do serial print on this, it's going to be an absolute chaotic disaster, right? But yeah, you are correct, though. Maybe we do need to put a serial print in this. Let's just test this and see if that magically fixes it. Oh, wait, close the serial port. Oh, it is. Okay. I mean, I guess I could just kick out the value of the mods. Print mod A. B, C, D, and E. What? Do we have a... Wait, how did that become a thing? Oct setup, not in the scope. That means that a bracket got deleted. So we need to find a bracket. Looks like octsaw is to blame. I mean, we were just working right here. That one goes to... That one should go to here. Yeah, so we destroyed a bracket? Oh, yeah, it goes down here. Wait, that doesn't make sense. Now, for the rounds here, we do all of this stuff. So this should actually end... All right, that goes to there, and then this for loop is inside of that for something, something, something. So we actually need... Huh? Hold on. My brain is starting to hurt. This one is contained here. That's contained there. This is contained there. And this one is that one. And then wrapping all of those, we have this one here, and then this one is missing its initial one because I accidentally deleted it because we were working right here. Boop. Okay, I figured it out. You guys don't need, no, don't give me line numbers when I do silicon. Fine. No, you guys are fine. Don't worry about it. I can figure these problems out. All right, so let's upload that. I must have just hit delete by accident on something. I should probably move that over here. My hair is too big. Okay, we're flashed. Back to here. And did it do anything? Well, we're in FM mode and waveform 0. And this isn't doing anything to wobulate it. So something is happening with my logic. 3, 4, 5. That was 4. This is 5. Nothing is happening. I mean, I guess I could have it evaluate the whole thing. It would just get rid of the checks. And then it would evaluate all this math, and it would come up with 2 pi times 0 I over 0. What's up, Speedy? Yeah, we're doing some pretty heavy math. But I did make a VCO, and it does actually kind of work a little bit. Well, the other modes work. This one works. I said. I said this one works. Jeez. We're looking at FM modulation right now, and it's not doing nothing. And I think it has to do with this. I tried to act, because it's a polynomial, and it's sort of like a sine of coefficient plus sine of another coefficient plus sine of another. It kind of is a regression of sine waves. Yeah, our polynomials aren't polynoming. They're polynomiant. I don't fucking dare. Burger King has half sizes or halvesies. I don't, huh? Second-hand burgers. I guess I'll go with a used burger today. So we have a bunch of coefficients. They're stored as floats. Then they're evaluated in a logic statement. And I tried changing the logic statement to see if they were 0 or not. I'm using default values in order to activate certain functionality out of this and leave out parts of the equation that we don't need. And so if those equal to 0 and they're not overwritten by the equation, then they shouldn't affect the output. And we see that evidenced by the fact that none of them affect the output. In fact, we're not getting any behavior out of anything. That is the problem, and I don't know what's going on. Half onion rings, half fries. Oh, that actually sounds pretty good. It's not really advanced math. It's just polynomials. Polynomials is not that crazy. I've forgotten more math than most of you have ever experienced in your lives as a control systems engineer by training. So what in the microcontrollers is happening here? We can use serial prints and we can see whether or not mod A, B, C, and D are actually being utilized. Let's do that. Print line, and we're going to make that mod A. That's going to throw a wrench in all of this code, but we got to throw wrenches sometimes. Sometimes you got to dodge a wrench. Yeah, I'm not one of those crazies that does math in their spare time. I had a coworker whose dad got type 2 diabetes, and in doing so, decided to put all of the information available to him on spreadsheets in order to figure out how to fix his type 2 diabetes. And so that was like full dietary information, it was just the full engineering send on that. He had charts and graphs and data. A friend was showing it to me, and I was like, this is just embarrassing for everybody who doesn't actually want to do all of this work. That's mod A. Mod A is unchanging, no matter what mode I'm in. Aha. Why are my default values not working? Mod A remains 0 at all times, and as I change modes here, it should be doing stuff. That's the problem. I've thrown wrenches and then regretted the chip in the concrete. Oh yeah, that actually sounds like a bad thing. House insured, try to be awake for 36 hours. Laptop is now resting on an office chair designed by Satan himself. What? Everybody's lives are falling apart this Friday. I commented that back in. I put that back in. That was this big lump. This is where we are supposedly writing values into these equations, but for some reason it's not. So we come up here and we have FM modu. Do these need to be... Let's look up Arduino default values. Arduino default values. Then if you use the function, you can either do this, or you can give it values 22, 2211. Arduino land is C++, unless the tab specifically ends in .c or C++ or anything else. So yes, you can do default argument values at the first declaration. Specifically, the values, don't specify the values again if there were a second declaration. All arguments with no defaults must come first. All defaults must be expressions that the compiler can compute in compile time, not code. The only quirk about default C++ is you can only omit values if there are no additional arguments. Yeah, that's fine. That's how we've been using it. My life has been falling apart many Fridays. Well, it seems like people's houses, like the objects surrounding them, moreover, are what's failing. Mod C does not equal 0. Mod A does not equal 0. So if mod A has a value and we are passing a value into this, math is fun. Yeah. I'm running a gauntlet of math right now and it sucks. So by all means, if given the default value of A, which we are doing, we should have mod A is equal to the mod value, the numerical value of the modifier, over 128 times sine of 2 pi times mod A times I over mod A1 plus mod B, which is defaulting to 0. So none of that should multiply out to 0. And our mod number... Oh, you missed it earlier, Uncle Joe. I had Uncle Johan. I did actually have gauntlets on. I had the electrical gloves on because we're not allowed to show intimate body parts, and hands are pretty intimate. So, you know, don't want to get in trouble with TOS. Show tear ducts. Gross. I probably could with the microscope, to be honest. I don't understand why this wouldn't be working. I mean, this, by all means, this thing should work. And mod A does have a value. It's declared in this scope, and we saw it to be equal to 0.00. So if it's 0.00, that means something, well, it's still afloat, so. My laptop has been in the garage since the winter. Oh. Got a tip to try recharge for 24 hours from a place so it doesn't burn down the house. Office chair is literally pain in the ass to sit on. Now I got a better one. Oh, I see. Okay, it's starting to make a little bit more sense. Yeah, those lithium-ion batteries are trouble. I actually took one of my 50 cal ammo cans and put all the batteries in it. I probably should also line the bottom with sand, but at least it's somewhat of a containment if things decide to spark up. But then again, lithium-ion batteries really only detonate when they're overcharged. If they're undercharged, they're just going to balloon. And the bag that it's in is designed to hold all that hydrogen and not start a fire. But having a lithium fire, yeah, is not that fun of a thing. I would hate to clean the soot out from the entire shop. I got to get rid of some of these old drone batteries that I got sitting around. They're sitting right under my foot right now, actually. My foot is right on that can. Pick up that can. So the spacing is weird. I just wanted to line up alike elements like sine, mpi, and stuff, just so that it was a little bit easier to digest. I like readable code, you know? I code very publicly, and so when I'm showing my code, when my code is dangling in front of so many people, I like to have that code be nice and neat and trimmed, and maybe a little baby powder on it. But what's happening right now is somehow we are not affecting any change into these variables, in spite of the fact that all the way down here, because this is FM modu, all the way down here when we invoke FM modu, we are putting 0, 3, 256, and then nothing else, right? And by all of the rules of the land, by the rules of the land of microcontrollers, that means that we should be putting a 3 into position A and a 256 into position A1. Oh yeah, I gotta get rid of this. That's why that doesn't line up. Right, so it should be putting 3 and 256. Salt water for a car battery fire to short it so it discharges. That's clever. And you do a half cell reaction, so now everything is coated. Lightning almost hit my house some months ago, 35 meters from me. I wish it could have hit and gotten a new house. I don't know if insurance quite works like that. Everybody gets fucked when insurance gets involved, right? 3 and 256. So we're putting 3 and 256 into the A coefficients. So then mod A is the number 3, right? So mod A is equal to 3, and it's a float just so that our math, you know, it's a float so that I can store the steps of the coefficient in there. So mod D is equal to 0, so we don't do that. Mod C is equal to 0, so we don't do that. Mod B is equal to 0, so we don't do that. Mod A doesn't equal 0, so mod A is now equal to mod B. Well, it's the sine of 2.0 times pi times 3 times I, which is 0 to 256, over A1 plus mod B. So by all means, this should work. Did I just hear a puppy? Is that a puppy dog? Hold on, I want to see if the puppy dog came downstairs. Did the puppy dog come downstairs? Is that what I heard? Nope, door's closed. Why did I hear a jingling collar? Oh, maybe she's outside. Maybe she's outside. Door's closed because the dog shouldn't be going up and down stairs. She's got an ACL issue, but I think she's almost better from it. It'll just take a little bit. 224. What do you mean? The order of mod DCBA. Yes, DCBA, because the way that this coefficient, I don't have the MS Paint thing anymore, but the way that this is calculated is, and this is the way it's, these equations are set up in Hajiwo's code. They're just these big polynomials, but what they do is they have different things being evaluated at different times, like nested in a singular sine wave. So like this sine wave here actually goes all the way to the end of the equation, but it initially starts with sine of one thing, and then it adds that to, whoa, another thing. So it's this plus this sine wave evaluation over here. So it's a way to scale the different elements of the coefficients, right? Mod AD's nuts. Sounds like you want a free CD. Okay, so yeah, it's a weird like nested sine inside of a sine inside of a sine inside of a sine inside of a sine. And the reason they do this is it's like scaling different factors based on the values that are going into them. It's weird ways to wibble about your wobbly waves. So we give it these values, and then these will default to zeros, which is what I assume is happening by all means. And then in the end, those will populate wavetable 2. So once it goes through all of that, each individual round, it'll set the value in wavetable. And we know that's happening because we've got a sine wave on the wavetable. That's just right there. Why then? I'm gonna show my wibbling waves on Twitch, and they can't stop me. They can't stop me. They may try. Mod D, those are the same equation. A1, B1, C1, D1, E1 wasn't in there before, but now it is. But for some reason, mod A is equal to 0 the whole time, and nothing is being passed into our... For some reason, like our defaults aren't defaulting, or they are over-defaulting, they're overwriting, but we definitely called upon this equation and gave it a default value. 3 and 256. So why then is mod A always 0? I can change wave modes here. Of course, we can't see what wave mode... Actually, I can. I can see it flash in front of the screen. This is on mode 4? No. That's 5. 5 is one of the... right after the one that divides. And if I change the mod number up and down, mod is not changing. It's probably changing on the readout over there. I can't quite see it from where I am, just because this thing is flashing by so quickly. That should be changing. That value should be changing depending on which mode we're in. So switch of the waveform number being the case populates the default values. The default values are not working. Mod is also 1023 over 8. So 0 to 127, which we observed. We observed that. So why then? I mean, the other equations worked fine. The other, what is it? This one up here. Waveform modulation of 0, 3, 5. That one works just fine. Hey, Syphilid 8, how's it going? That one works just fine, and it does exactly the same thing if the debouncer fell. This one is going through one check of the waveform per loop. So we take a switch of the waveform. We have all of these cases here set up in exactly the same way. Our brackets, bracket, that's contained. Brackets, contained. Got all of our breaks at the end. All of our semicolons are in place. The function should work. It doesn't. Let's try moving the serial print up to before we do the evaluation and see what happens. So if I take the serial print and I move it to the beginning of the program, beginning of the function, upload that. All right, Poopsie Doodle, thanks for hanging out. Hey, thank you guys for hanging out. Oh, we got a bunch of people here. At least we're doing something exciting today, which is hitting microcontrollers over and over again until they cry out in pain and give us a data point. Unfortunately, it does involve big math, big polynomial math. I mean, does 0 equal 0.00 for a microcontroller? I think it does. So our wibblings are not wobblings once again, because we didn't really change anything. So if we look at our serial prompts, oh, hello. Why is that running only once per serial print? Oh, because we're outside of the for loop. So that is equal to 3.0. So what is zeroing out our coefficient then? MPi? I think MPi is evaluating fine because we've got a sine wave here. Plus mod C, mod B. Is it maybe doing stuff out of order? What if I put some parentheses around everything? That one probably doesn't need it, but I'll do it anyway. And then do this. Yeah, wait, that's, okay, I don't need that. Well, actually, that should probably be evaluated, yeah, on its own. We're just going to separate everything out with parentheses and see if that works. And then we'll do, this gets a parent, this gets a parent. My voice is getting a little rough. Because maybe it's evaluating the math a little too early, or it's not doing the math. It's like multiplying something by 0 by accident. Oops. I don't know. Microcontrollers get weird with the order of operations. So we know that 3 is being passed into the equation. It's just for some reason becoming 0 in here, which doesn't make any sense. So my theory is that mod A being 0, something along the line here, like our mod B sitting here on the end, is actually evaluating to become 0, whereas it should be adding 0 to what's already being evaluated. That's my concern here of what's going on. What's going on? Put a space there. 2 spaces, in fact. Oh, I still need one more in here. and then one more over here. You gotta hold the microcontroller's hand sometimes, just to make sure that it's not evaluating things that it shouldn't. So now it's going to do the entire numerator first, and then divide it by E1, just in case. Do I have a serial print going? No. I'm going to cough. There we go. Do the thing, do the thing, come on, let's go. Let's go, 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 go. Code, code, code. Load it in, 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 load it in. I know, yeah, with anything microcontroller, more parentheses good. I didn't do a serial print on this one, so let's just see if... Nothing! Still nothing. Still nothing. It's nothing, honey. Why? I'm gonna cough again, hold on. Why? I did all the parentheses. I did everything I should have done. And yet, here we are. I do it. Huh. For some reason, it doesn't initially evaluate. Yeah, it doesn't do anything with that. Skill issue. Hold on, I'm gonna cough again now. Uncle Johann has triggered a visceral reaction trying to expel horrible things from my body with his comments. Mod over 128, sine of this divided by that. We've isolated it out so that this coefficient is not getting in there. If mod A has value, then rewrite mod A with the result of this equation. Print line mod A serial print line mod B. This is going to make a huge mess, but we can just see if for some reason, I mean, it doesn't make any sense. Let us observe. Why would my values be eliminated by not running a bunch of if statements? It's not like we have breaks in the end here. And then by the time it gets here, it equals to 0. Is m pi a thing in the RP2040? Yeah, it should be, because we've got other... Yeah, these are 0, no matter what mode I'm in. What the fuck? Like, what? And then this knob is, like, in the middle. Okay. It doesn't make sense to me. These are inside of the scope of the rest of this thing. They're all declared, and they're all created by this right here. We can observe, before we get into the for loop, that these are actually being utilized. If I make another float, if I just make another float operand, and I just take, well, mod E is equal to operand is equal to that, and then operand, and then, no, that doesn't make any sense. Hold on. I don't like that. Take mode B, or mod B, and turn that into the operand. Because then it'll evaluate this part of the equation, and then evaluate the next part of the equation and add to that. But then I need this down here gets evaluated later. Not that we're using it in any of these, but... All right, we'll put operand in here for now. Yeah. Like that. And then mod2 wavetable plus operand. And here we do plus operand. Serial print line operand. Let's see what that looks like. I don't know if operand's the right term. Yes, yes. Oh. Prinlin. This is cursed. This kind of math is cursed. Okay. Okay, now we get a changing value. Oh, and look at our wave. Our wave looks like the chart. Why then would it be zeroing out if I go to overwrite it? It really just didn't like that, did it? But now it actually functions. Look at that. Fold mode 1. Yes, yes, crunchy, crunchy. Crunchy stars. One of them, of course, doesn't do anything. We need to change that into our operand, I suppose. Well, shit. Why did that fix it? And then this one too. And then this one too. And we're still abusing the variable. I just wanted to abuse the default, you know, because we've got all these floats declared, but I guess we're doing it this way. Like if it's a default value, then that should default to equal to 0. Strange. I mean, that fixed it. They're not exactly fixed variables. Strange. Well, we've got a big boy microcontroller, so I guess it can benefit from all of the overhead. So let's upload that and have a complete set of code here. And then we can run through the modes and see if they're actually working. And I'll bring the speakers over and we can listen to them too. Tuning, it's going to be a different affair. I need to reverse the CV handling. I don't know why that's not quite being handled correctly. It's strange. The mod comes in correctly. It's the CV that's coming in backwards. Yeah, it's not. This ain't just 8-bit. We got all the bits. All the bits. It doesn't look like there's a difference, but there is actually a difference between all of the modes. Uh-oh. What mode is this? Waveform number 4. Mod 2 wavetable, oh, plus mod D. Oh, wait a minute. So what's happening there? D and E, oh, that does break everything. Let's do float operand 2. And then this one is operand 2 is equal to, I forgot that they were completely different. Mod E1, operand 2 is equal to that plus operand 2. and then this one starts it, and then has 3. Okay, I'll load that in. That'll fix mode number 4. We got to figure out what's going on with the EEPROM too. Why are we not saving to the EEPROM? It was very easy to do with the ATtiny. It's just the RP2040 should have a pretty big EEPROM connected to it. I don't know if pin 0, like position 0 rather, is unacceptable, or you know, if I need to just tweak something a little bit. But all right, so that loaded in, and we are already looking at waveform 0. So 0, 1, 2. Oh, that's, wait, oh, okay. I need the serial printout to tell me what waveform I'm on. We're on waveform 3. So the next one, that should be 4. Let's just double check. That is indeed number 4. And then this one is number 5, which includes all of the polynomials, but it doesn't, well, oh, okay. That one doesn't do nothing. What's going on with this one? What's going on with number 5? Waveform number 5 should involve every single one. Did I misplace anything? I don't think so. It doesn't appear to be responding to mod very well. Oh, wait. Yeah, that number 2 in there is messing it up. Oh. Yeah, there we go. What the hell is an operand? Hold on a second. I just used some random math term. Oh, okay, so that actually does... Okay, that makes sense. Now I remember. Programming, programming, programming. Okay, so that's 0, 1, 2, 3, 4, 5. Well, 5 is a little cursed, isn't it? Should it go down to like no... There is an effect. What does 5 look like over here? I gotta figure out who made this. I thought it was Ben Gizmo, but 0, 1, 2, 3, 4, 5. Oh, it just always looks like a mess. Oh, it just always looks like a mess. It doesn't exactly resemble this, though. That's not exactly the same. Yeah, something's a little messed up with this, isn't it? That doesn't quite look right. Looks like it's maxing out or lowering too far. In which case, what are we doing? We're doing... Oh, is it over 128 or is it a different number? No, it's over 128. Sine of A plus mod 128. I think we've got that. It's the constant breakbeat of your... These are the breakbeats of your life. Z. Operand 2. Operand 2 is equal to... This is the second operand. This is the first one. The first one, 2 m pi mod d times I. 2 m pi thingy times I over thingy 2. Did I divide it? Yeah. 2 m pi thingy times I over thingy 2 plus the results of the previous thing, and that's all within the sine function, plus the results of the previous thing, and the previous thing, so is this, mod over 128. First one doesn't get a mod over 128, second one does. And it evaluates that. That should be correct. Why do you not resemble the waveform that I'm looking for? Bum, bum, bum. This is all within the first sine. So it's this whole business. So we got sine of 2m pi I over 256 plus. Then we've got this one plus this one. And that's what's creating that sort of modulated up and down movement of the, like, the first sine wave is there, but then the other one is offset by a second sine wave. But that's not what we're seeing here. What we're seeing here is cursed. One of the values is either too big or too small, and it may be due to whatever I'm doing here. So I have two operands going into this thing just so that my numbers are clean, and I can pull this one in later on. So we have sine of this thing plus the second thing, added or divided at the end. This one is it over 2. What does that one look like? Whoa. That sounds dirty, dirty, dirty. I really need that indicator to tell me where we are on the waveforms. Yeah, that one seems messed up too. So the ones that are using this extra coefficient are getting like turbo effed. And they look like nonsense. Something bad is happening here. Maybe it doesn't like my 2 lines of code. But then again, we got away with it here for these. These work just fine. So we should be able to get away with this one here and get our second operand out of that. Sine of that. Ah, there's a bug. Oh, was it just a fluff? Maybe it was just a fluff. It's still mod over 128, still sine 2.0, m pi, mod E, and D. Mod E and D are being passed in, and they should have values. We could check, or I could just check what operand 2 is doing. Let's check what operand 2 is doing after we declare it. Actually, we'll do after we do the overall evaluation, because it should be the same every time. Try that. All things considered, it's going to be kind of a crazy progression of numbers, isn't it? Well, no, because mod E, every time it's called, is going to be the same thing. We'll just get to see the default value going in as I go through the different modes. What? Println again! Why do I keep printlning? Oops. Print line. Try that. See what it do. The Raspberry Pi, for some reason, the RP2040 takes a long time to compile. The other way to use one is you could just drag and drop your code into it. You can use Python, and then your code is just always there. So we're looking at my println. My println is at 0. I go through the modes. 1, 2, 3, 4. Now I've got a negative 0.7. 5 is negative 0.22. 6 is nothing. 7 is nothing. 0, 1, 2. Wait. Why was that one nothing? Nothing. Three of them should be using it. One's divided by 2, and then, so 0, 1, 2, 3, 4, 5, and 6. But 6 was 0. 4, negative 0.7, 5, negative 0.22, 6 is 0. Oh, I didn't put the numbers in. Dun dun dun. 0, 1, 2, 3, 4, 5, 6. 256. Oh, and I forgot to put these in, I guess. 17, 111, 1989. 17, 111, 1989. So 17, 111, 1989. 1987. Leave a space there. And we got to do these. 0, comma, 0, comma. Line up the elements so that it's more readable. Oops. Oh, thank you. God damn it. I hit Control Z and it blew away like a minute of, a couple seconds of punching numbers. Delete that back into place. There we go. Whatever, I'll let that be weird. 1711, 1989. Okay, so that gets everybody into position. We'll get that in and check out that value. Waiting, waiting, waiting. Even though our end results are not correct, so I don't know what's going on with that. I don't know what that's supposed to be doing. Parenthesis before numeric constant here. Exit status 1. What did I delete by accident? Semicolon, semicolon, semicolon. Comma, comma, comma. Didn't edit any of that stuff. It's just back here a couple things happened. Boop, 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 boop. Huh? It's looking for a closed parentheses before numeric constant. But I didn't edit any parenthesis. And it's highlighting the line that I just edited. Here reporting for Doodle. Case 6, number. No thing at the end. Parenthesis. Break. Why would it be? Oh, 256? There's nothing wrong with 256. After the number 256. Oh, there's no comma. There we go. Geez, sometimes the brain does not allow for you to see stuff like that. That went completely under my brain dar. I don't think I could pass a Turing test right now. We've been doing a lot of weird microcontroller stuff today, so. Oh, serial port. Damn it! I gotta do the whole thing again. Of course, this still doesn't solve our problem. Our problem being that our operand is kind of a funny number, and I'm not really sure if it is what it should be. Oh, Syphlet8, actually that message was a sub. Thank you for the 38 months, Syphlet8. Hey, that's very nice of you. Yeah, we had a big gonad raid. Big dangly gonad raid. All right, so that's up. Look at the serial. Mode 0 doesn't have this stuff. Mode 1 mode 2, mode 3, mode 4, negative 0.7, mode 5, 0.22, mode 6, 0.33. So there's mode 6 doing its thing. That looks a lot different. Looks a lot different, or I guess you guys have, yeah, you guys can see the scope view there. Boy, that's a nasty wave. And this makes it nastier. Nasty, nasty. Nasty. Nasty waves. That's a nasty, nasty wave. Very crunchy. And then we just have this one, which still does crunchy stuff. This is mode 5, and it really should not look like this. Mode 5 should look like 0, 1, 2, 3. Oh yeah, the F of 5 should look like this, and it should get crunchier and less crunchy. The original, it's actually got much more amplitude than the original wave though. So maybe that's what we're running into, is the increase in amplitude is killing the wave, and it probably needs to have something to divide it. Because look at the amplitude on this thing. That goes up to 1,000. The other ones only go up to 5. So this should be contained within. It should be half of what it is right now. So if we divide it by 2, isn't that what this does on 5? Zero, 1, 2, 3, 4. 5 is not divided by 2. So let's try dividing 5 by 2. In order to divide by 2, all I need to do, pop that sucker in right there. Upload the code. I'm fixing it. I'm fixing it. A linked did not want to make a linked alien KD ratio. I don't know. I don't know what you're saying. 0, 1. That didn't change. 1, 2, 3, 4. Let me open up the serial port. Oh, we're on 5 right now. Look at how much different 5 looks. Yeah. Well, it's not exactly what we saw. I don't know what frequency is chosen there, but you can see how the added coefficient is simply adding another sine wave into our wave. It adds a second sine wave in there. And then this makes it real crunchy. Real crunchy. Real crunchy in that sine wave right now. That actually fixed it. That did fix it. Yeah, we'll hear the waveform in just a second. This one is utter chaos. This one's the one that comes after that. What's going on with this one now? Well, the 6th one does have... Whoa, okay, that makes sense. But this one goes up to 1,000 again, so we need to divide that one by 2 as well. This is the one that gets the dividing right here. And you can see that one only goes up to a maximum of what's already established as our maximum. So yeah, we've made quite a bit of progress yesterday and today. Today, mainly cleaning up the way that these multi-expressions, the polynomials, there we go. The way I'm going through the polynomials, I was using these default values and trying to overwrite them, which for some reason just blew them up. It didn't write any of the variables. So instead, what we're doing is assigning 2 new variables, which are operand and operand 2. Operand 2 gets evaluated first, and then it comes back in once we make the waveform. And then operand is just our normal thing. So we've got our 2 pieces of the equation are built separately depending on whether or not those default values are populated. And then at the end, I've got 2 different mod 2 wavetable equations because one of them might involve dividing by 2. And so to enable that, that is the first variable, oops, we're going down, our first variable in the function call. So now, in order to evaluate those dual operand things, I am dividing it by 2 because those numbers get inflated because it's 2 different things that are kind of crashing together there. So once I upload this, I will achieve a singularity and become a singular point in the rest of the universe, and I will have descended to a being of pure energy. Here we go. When it gets out of spec values, then things just get kind of crazy. So that will become a different wave. I still need to bake in the EEPROM and the LED stuff. Yeah, I don't know what was going on. It was just zeroing out my variables, and so everything was chaos. Okay, so we're back with new code. So we're going to go to waveform 6. So 0, 1, 2, 3, 4. Ooh, 4 is crunchy. 5, 6. Look at that. It looks like it's better. And then it gets super crunchy when you do the mod. But now the waveform actually fits with our audio output. So since this is a modular type thing, the output is way out of spec for normal speakers. I got I guess plus minus 2 volts according to, well, no, we're on channel 3. Yeah, plus minus 5 volts. So this is like blow you up levels of, why is this, hold on a second. How do I return this to its normal ranges? Bud, can you just go in like normal scale? 5 kilovolts. There you go. Offset 0 kilovolts. There we go. Okay. So yeah, plus minus 5 volts for that. So what I need to do, I'm going to get the speakers, and then I'm also going to get, whoops. I'm also going to get my output attenuator. I think I have multiple output attenuators, but I'll just get the one over there for new. For new. Let's get this. And then I need this thing. What is the hex size for the rack? Oh, actually, this is it. Okay, never mind. I've already got a thing for it. I just need a battery. This is the thing that Mahala sent in, the DeWalt gyroscopic screwdriver. It's actually really fun to use for the modular rack because you can undo all of your hex things. Look at this big ass machine. Oh, I can't get into it. Here we go. There's one. And I'll get the other one down here. This is just a little multi-channel attenuator. It's just 100 kilo ohm resistors and some 100 kilo ohm potentiometers. It's very simple. It's a passive element. It doesn't need power. Probably put this stuff on top of the actual synth so I don't lose the bolts. Grab that, bring it with me. And then we need a cable, and then I need the speakers. Speakers are just over here. Actually behind all this nonsense. Don't want to knock over, burn the subs. You guys are going to hear it through my microphone. I'm not going to put it into the system audio. So there's going to be a little bit of frequency manipulation and compression, which is important because if it blows out my ear sockets, it won't blow out yours. Turn those on at a low volume. Try to get them over here. We'll just put them over to the side, I guess. These are just Amazon Basics speakers. All right, and then, oh, audio cable. Oh my goodness. Oh, you know what? Instead of that, we want to get it on screen. So I'll take this and I'll put a T in it. I need better T's. These T's don't really work with the scope very well. the ones that go at a right angle, the T-posing ones. They're not quite what I'm looking for. They kind of crowd the controls for the scope. I guess I could also just get little cables. Are you making more parts for this, or are you close to done with this project? I'm close to shelving the project for a little bit because we need to work on Burn the Subs. Oh God, I got this mess to deal with. I'm close to shelving it for a little bit, but I do want to make some actual modules with this. And I want to put them together and get them to Dave and Julian. Those guys are, God, my voice is getting real scratchy. Those guys are incredibly patient, but I don't want to try their patience. So I would like to actually make modules that they can use in their synthesizers, and then I'll be happy. And we still need, thank you for respecting my ear holes. A lot of what I brought to Twitch when I came to Twitch was my knowledge of audio stuff. I'm a, engineers, jack of all trades, all that stuff, but I've done a lot of audio stuff in my day, and a big portion of Twitch, like people say you can get away with really crappy audio, and a lot of people do, a lot of streamers do get away with really truly cursed audio, but only to a point. Why is this phasing in and out? Strange. Only to a point. And if you push your luck, people wonder why they're not getting an audience, and it's because their audio is peaking all over the place. So part of what I evaluated when I started streaming was, how am I going to make my audio sound as good as possible, and how am I going to keep from blowing up other people with my audio? So compressor and frequency manipulation, and you put that through recordings. Oh, that's headphone input. Oh wait, this came with its own cable. I don't need to use any external cables. I'm the wiener. Dear God. Okay, let's go ahead and turn that down. Let's turn this off, plug it in, turn it all the way down. Oh, it sounds like an angry bee. Ugh. Go ahead and put that control voltage in the other direction. Oh, that's that. Wait, the 1V per octave is what I want. Why is this not? Show the wave, you freak. Huh, weird. It's like the sound's getting through, it's just not contacting properly inside. Why is that happening? Can you guys hear that? What is going on with that one? Ugh. Oh, it just adds like pain to the sound. Ugh. Yeah, this thing is nasty. Shortwave numbers, yeah. I think it's making my dog bark. Sounds like a kid's toy I had in the 60s, yeah. That one's just nasty buzzing. Maybe at lower frequencies that one makes more sense. Ugh. Play Freebird. Don't you find free bird? Okay, make it stop. Stop it. Jeez. Whew. Okay, so yeah, this makes some pretty nasty waves. It's neat. But this is only in this one modulation method. If we go to the other one, boink. There we go. So these are a little bit more wieldy. I need a control voltage in here to have full control over the mod factor, which probably I should put that into the math so that I have full control when this thing is at 0 of this variable. I think that the way it's doing the math is not quite right. I should still have full control with this knob. Well, what's our default note? Oh, it's way too high. Yeah, it looks like it can get into a bad numbers situation. VCO and ADSR. Yeah, I need something. This is just this is what this thing's job is. What it's doing right now. It's just making a tone. Look at that. Not a lot of wave difference on the scope equals a very large amount of sound difference. That gets real crunchy. That's cool. Okay. Next. That sounds like it almost has like a flanger across it. Neat. I'm keeping it at low tone so it's a little bit more, yeah, curse DTMF. I used to work with that a lot. This one seems to be like the same one. I don't know why. Maybe the numbers are just a little bit different. Oh, the buzz of a square wave, bringing warmth to all of our hearts. Come on, man. Why is my scope is like acting funny about displaying these because of the hookup? Lots of cool sounds in this thing. It's funny, all the sawtooths go in one direction. They don't go in the other direction in this one. Okay. Ah! Yeah, it seems like the carrier signal is always there. You always hear that tone, but then these will add little wibulations to it. That one just sounds filthy. So let's check out what AM does. What the? Whoa. It sounds like an overtone. Yeah, depending on the algorithm fed to the oscillator, it can do flanger-like modulations. Yeah, and you get some real heavy metallic basses. All kinds of cool stuff, right? Let's take a look at that a little further out. Come on, man. Something's wrong with this specific one. Oh, there, I think I just fixed it. So this changes the frequency of that second oscillation. and it makes weird kind of beats and overtones. You guys probably can't hear it much. I can turn it up, but it's like everybody get in the hover car, we gotta go. Next. Actually, am I? Yeah, I'm on waveform number 1. Maybe a bit higher frequency. 2, 3. Okay, something's not working with AM. 4, 5, 6. Yeah, it's the same thing with the default values. Okay, let's shut the hell up for just a second here. I hear it all. Turn on my compressor. Okay, AM is broken, and I think it's the same shit that's been going on with FM. AM, so this is the waveform modulation. This stuff does work. Do we get the saw? Yeah, I guess we do. Number 1 is saw. I think that one looks more like a... It doesn't really look like a saw, does it? Huh. Oh, whatever. Okay, waveform table. We have the AM, and that one's FM. So AM is using waveform modu, and it should be int A and B, but for some reason, where is that? That one's way up top. Yeah, see, I'm doing the same thing here, so I'm gonna have to do float operand is equal to 0, and then if mod A, then operand, and then down here, we have operand again, plus operand. And then instead of mod A, we just have our operand. That word is starting to get semantic satiated on me. And then we'll upload that. And that may fix AM. Fix AM. Of course, I'm still going to have to tune this thing. Yeah, there's a lot of really cool stuff that this thing is doing, I'm seeing now. Hajiwo has put in a lot of cool stuff into the code. I have completely eviscerated the code and turned it into my own thing, sort of, but it's still mathematically doing the same stuff. We just had to scale some things a little bit. We're waiting for code to upload, and I accidentally had the serial port open, so I'm going to hit upload again. You're going to be saying operand on phrases out of code. It's just a meaningless word to me. I've said it so many times today. What is that word you just said? I don't know. I hear nothing when I hear that word. Just an E in the background. Flashing F. Wrote to F. Bada bing. I don't know why it doesn't output it first. I seem to have broken AM. That one works. Whoa. Wonder what that sounds like. Oh, jeez. That is a hell of a thing to listen to. Next. Whoa. Why did the first one didn't do anything? Operand would be equal to 0, so it should just be a sine wave. All right, let me open up the thing so I can see what mode I'm in. This is waveform number 3. I mean, I'm hearing it. It's blah, 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 blah. 4. Whoa! Look at that waveform. That's cool looking. Wait a minute. Weird. Yeah, this just manipulates the second frequency, huh? I don't really know. I think the math may still be broken. Zero. put the input through multi-dynamics. Yeah, something to keep it from killing me. I guess waveform 0 does work, but they all seem to do the same stuff. My question is if my second, like, are these actually doing stuff? Because according to this modulation mode, under AM, 0, 3, 5, and then these involve the second one, and then these start to use them as, are these floats? Oh, they may not be floats. Maybe that's what's going on. No, they are floats. They are floating. If we just remind it that it's doing float math. Of course, wavetable of I is an int. No, wait, that one's a float table. That's a float table. I don't know if that'd fix it. I think my logic is sound. Float operand is equal to 0, and so if there is a mod B, then it will evaluate this. And if there's an A as well, and there usually is, it'll evaluate this with the value of A. Before this was knocking them to 0. So, oh yeah, sine 2.0. And then everybody floats down here. Let's try it. I don't know. That'll give me more granularity if it properly floats everything. And I guess in the background, what I'm going to do is I'll work on making it use EEPROM and do the LED thing, do the little LED flashing, and then later on down the line, like when I figure out the chord VCO, the sky's the limit. I can make it bring in like external audio even and have it operate on it, given the speed. Oh, COM4 is still open. We could make this into some kind of an accursed filter. We'll have to look up digital filters because I know nothing about them, but. Yeah, I got to make it load in the value properly. For some reason, when we boot up, this is just going to be blank. I like how even when uploading software into the thing, the square wave is still present. Yeah, exactly. The circuit is a modular module. Okay, so we have software, but nothing is happening because the waveform hasn't been reminded of being a waveform. So do that. There we go. Well, it seems to be about the same as it was last time. They do have slightly different sounds. This has more ringing than the other one. Oh, because it's nasty. Huh. Oh, and I need to redo how these knobs work, because I want full control with this knob. Which I have right now. It's just because of the way things are scaled. When I unplug this, it goes to a mid value. Ring module? Yeah, I guess. But shouldn't it not start so dirty? I don't know. I like how radically different these all are. Yeah, I guess we're amplitude modulating the original, and then this is adding accursed sine stuff to it. Huh. Ooh, that one's nice. Oh my god, it got weird. Ooh, spooky ghost noises. You know, when I tell girls I want to play radio operator with them, they don't understand that this is what we would be doing. We're just playing radio operator, right? I get slapped a lot. Yeah, it was rounding up the values because of 2 and 2.0. But I mean, like, sometimes it didn't. Microcontroller math is always very weird. You can't be too confident that what you want to happen is happening. I think that divide by 511 was also turning things into int as well. The wavetable is done in non-int space, whereas the other tables, like the PWM output rate table, is done in waves. Or sorry, ints. It's done in ints. Sorry, I'm confusing myself. Crunchy. Wee 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 wee. Oh, that takes a little bit of the edge off, huh? Whoa. Oh yeah, that's because this is a different mode. It seems like the octave is working. What is that glitching though? I guess it's there. Yeah, no more glitching. I am hearing something in there though. It's a do 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 do. Do 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 do. So what is causing that? You can see it's wibbling a little bit. Maybe that's ground? My filthy ground? Yeah, it might be that it's writing every time. If I make it only write when it has to, we might avoid that. Hey, that's fun. So yeah, I guess it works. Sounds like an angry bee. I have a little bit of work to do still on this thing. I'm gonna do that tomorrow, but I don't think we'll be streaming tomorrow. So I'm gonna try to finish this up. And I guess tuning is just a matter of, yeah. But then if I build in the thing where it's not creating the waves every single time, it might clean up the sound a little bit. When you change the wave, the thing doesn't happen. Let's go to one where like a normal old sine wave. There you go. Boy, having a smooth sine wave is much different than having all these other kinds. That feels so much nicer. It feels softer. Everything seems pretty stable. As I change this value, it's going to reevaluate the tables and create a new 256 table. He's stable now. Maybe the other modes are just a little bit funky. Oh my god, the strength of a square wave. Hey, mahalo! Good Friday as well. Wait, is it Good Friday? All this does is amplitude modulate it. Thanks for the 55 months, mahalo. I actually just mentioned to you because we took the my attenuator off of the modular synthesizer. Oh, it's the famous Good Friday. We're supposed to have a wonderful Friday today. I think we already called it a terrible Friday because everybody's houses are exploding. People are having like washing machine issues and stuff in here. But yeah, I mentioned you because I use the auto screwdriver on the rack. That thing is paying for itself. Yeah, we got this thing to work. It was a bit of a cursed microcontroller math thing going on. Let's turn this crap down. A little bit of a cursed microcontroller math thing going on where we have default values, but once those values are declared and defaulted, if I try to store a new mod B, it will zero out for some reason, and I don't understand why that would happen. Because I was taking these floats and I was punching them back in. I was using them as operands. So instead I made a variable called operand, and I used that one to go through the equations, and that works. Yeah, we don't have values. What are you talking about? But yeah, we got this thing to function and make some pretty crunchy noises. That was the wrong knob. Blah, 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 blah. Still feels a little weird what's going on in this. I don't know what that's supposed to be precisely. The PWMs probably look crazy on this. Oh yeah. That's channel 1. Weird. They don't look much different, but they have much different sounds. A sine wave modulated by the square root? I think that's exactly what it is, because what it does is it... Oops, sorry. Right there. What it does is it makes the wavetable first. So under AM modulation, it's going to create a saw, a sine, a square, triangle, octave saw, and then it uses just some other sine modulations, and it then puts it into something that makes the wavetable. Wait, is this? No, that's waveform. Hold on a second. Down here, all these little modes work in the same way. What you basically do is you make your waveform table. So here are all the waveform tables, and this actually isn't using a saw or anything like that. But then it puts it through this accursed thing. So I wonder if I could probably just put like a saw wave in there if I feel like it. These are sounds that I've made with a milling machine. Oh, the especially bad ones are the ones that sound like this. Crunchy. I wonder if some of these need to be scaled a little bit if they're clipping. That one's one of the cooler ones. It just looks cool. I wonder if that would work better as a LFO. I'd use that in my music. Yeah, there's some cool ones in here. So my plan is to build as many of these as I can. Once I order the new boards, I'll probably make a batch of 10 of each. Yeah, definitely. I'd love to hear it. Somebody uploaded music the other week, and it was great. Really cool stuff. Yeah, okay, enough. I don't know what musicians are made out of, but they can listen to shit like that all day, and it's all just one note. You saw that I tried to change the note every now and then to keep people from getting like super sick of it. But when Julian and Dave get started, they start with one tone, and it's usually a C note, and they'll tune to the C note, and I'm like, shut up, like, just stop it. I can't listen to this anymore until they finally, put all the effects in it and make it do cool stuff. So anyway, I'm going to think about maybe hiring a barber for the day and getting my hair did, because this is starting to get a little bit ridiculous. But we're going to take a break. I'm done for the day. We're approaching 4:30. We finished kind of early because we actually accomplished what we were going for. I'm trying to build that voltage-controlled oscillator, and I succeeded. Ha-ha! I am the wiener. I win. I won today. Mostly. We had to do a bunch of like cursed microcontroller math, pull some operands out of equations, and make sure that things all evaluated properly and as floats, so that we got that decimal precision that's important, because you can't just do, if your ranges are supposed to be audio frequencies, you can't just do integer. There is still tuning to do, and it may affect the code a little bit, but some behavior stuff has to be reversed too, because of the direction that certain knobs move in, or rather the control voltages, the direction the control voltages come in at. needs to be reversed. But I'm done for the day. My brain is soup. We've gone through the cockles of this code, and I've almost got a numerical understanding of exactly how this thing is working. I should revisit that AM modulation. Might be a little bit crunchy because it's maxing out on one of the waveforms, and that waveform might need to be scaled in half. I don't know. But for now, I am going to put a pin on this one. We're going to work on Burn the Subs next week, and then early next week, when I'm done whatever wiring I need to do for Burn the Subs, when all that wiring is put in place, we will then work on the VCO chord. This is going to have slightly different software on it, so we're going to have to take a look at that software, and I'm going to have to do some rewriting on it. That'll be complicated, but we can use what we've done today as a jumping point, and there will probably just be a little section of this that makes it output chords. Yeah, congratulations on putting your knob somewhere it was supposed to be. Thanks. I try very hard. Here's the end card. This has the Discord on it, if you guys were curious. Probably weren't, because I'm hammering away at the Discord during the entire stream. But thank you, YouTubers. Thank you, Twitch people, for making a name out of me, I guess. That's not really true, but it'll eventually happen. So thank you guys very much. Yeah, happy Easter for those that celebrate. For those that don't, I don't know, go fuck yourself or something. Whatever. No, I'm trying to be controversial. No, but yeah, anyway, whatever. Have a good holiday if you guys have a holiday. Otherwise, try to recuperate and get ready for next week, because we're going to hit stuff hard. No, we're not. We're just going to work on projects. Thank you for the raid, Flatulent Gonad. Is anybody doing anything interesting? Let's look at Twitch. I got to go take my puppy for a walk. It's a nice day. It's a nice day for a puppy walk. Who's doing ish right now? Rabaz is doing Noita. Oh no. Sir, you're being hunted from Tomato. Ella is doing My Summer Car. Paleontologizing is Behold the Easter Bilby. I don't understand what that means, but if you guys are interested in a science tech, Paleontologizing is a good channel. He does a lot of good stuff. So anyway, I'll leave you guys with that and shut down OBS and kick my computer. So good night, and I don't know.